Introduction to Building Bitcoin Integrated Applications. This is a course to teach you more about Bitcoin and how to develop applications with Bitcoin. So hopefully you know exactly what this video you're watching is. In this course, I'm going to teach you Bitcoin basics, Bitcoin tooling, Bitcoin nodes, and Bitcoin application deployment. But the first thing I want to do in this course is to ask you, the audience, what you know about Bitcoin. Usually I hear a myriad of responses like these.
Bitcoin
Bitcoin
is falling in the ocean.
And trust me, I know the discourse in Bitcoin can be overwhelming from both the proponents and the detractors, but all I ask is that you keep an open mind during this introduction on how it works and develop your own informed opinion over time. So before I get too deep into this course, I did want to address who this course is for, who the target audience is, and who would benefit the most from watching this entire video. This course is aimed at developers who have some programming experience and would like to integrate Bitcoin into their applications. Parts of this course are designed for individuals who have a budding interest in Bitcoin and would like to learn a little bit more about why it was created and how it works. But my focus in the majority of this course is to educate developers on how they can make applications that integrate better with Bitcoin Core. Some things I don't cover in this course are Bitcoin protocol development, wallet development, and to anyone who might still have this question burning inside of their hearts, I will not be covering any other cryptocurrency besides Bitcoin. So actually, let's start with why Bitcoin was made. A lot of people don't know the problem Bitcoin is solving. Money already works fine. I can pay for things. What is there to solve? Well, I would answer a lot. There is a lot to question with the global monetary system. So now let me pose some of those questions to you. So here's a quick quiz. It will be focused on a country that manages the supply of the currency underlying 58.85% of foreign reserves as of Q1 2024, the US dollar. But because of the dollar's predominance, the US's monetary policy actually affects everyone. So in this quiz, really take some time to think about what would be a reasonable answer to each question after I show it. I'll have a 5-second pause after each question slide, so feel free to pause if you'd like more time to answer. Or guess, because I'm not expecting you to know any of this stuff. All right, first question. What percentage of the US dollar do you think is backed by gold? Well, what if I told you it's actually 0% and that the dollar hasn't been backed by gold since 1971? Sound crazy? All right, let's do another question. What percentage of bank loans need to be backed by actual US dollars? You might think 100, but slow your roll. Okay, so the answer to this one is 0% as well. Bank loans have a 0% reserve requirement as of 2020, during the pandemic. Okay, last question. How much debt do you think the US government has? And the answer for this one, over $1 trillion. And the biggest lender is the Federal Reserve, the institution that's responsible for managing the money supply. Now, the reason I ask these questions is not to cause you to despair or throw you into disarray. It's to open your eyes to questions you may have never thought about before. Because even if you've never paid a second thought to how your country manages their money supply, it affects you, whether you like it or not. Satoshi saw Bitcoin as a way to opt out of government-controlled money, so that one day, the value of our savings wouldn't have to be so heavily impacted by the decisions of government institutions. Okay, now we can transition to what is Bitcoin. Bitcoin is a currency, like the dollar, yen, or peso, except unlike all those other currencies, it isn't controlled by any one government. It's a little bit like gold or silver in that sense, except it's all digital. So my second point is it's a digital native asset, which means the system relies on the usage of computers and the internet to propagate transactions. It was an important milestone in the digital currency space since it was first released in 2009 because it solved something called the double spend problem using game theory and system design. People value Bitcoin for its properties of being scarce, immutable, sovereignly held, and permissionless. So let's look into those 4 properties. First up, scarcity. Bitcoin is the first digital asset to successfully have engineered scarcity, meaning it's designed to never exceed 21 million coins in issuance. This is accomplished by giving out a digital ledger, which is like a database with information about payments, to anyone who wants it and allows the users to choose which rules to enforce. If you download software that's compliant with the network rules that the majority uses, you'll enforce the same things, which happens to include the 21 million Bitcoin cap. If you decide you want to change the rules, you can, but you'll eventually have a database that's out of sync with anyone you want to pay. This scenario is called a fork, and it's happened many times in Bitcoin's history, but we won't be talking too much about those. Immutability. Reversing a transaction once enough time has passed for a transaction to be considered final, like 6 confirmations, is practically infeasible. For Bitcoin to work as a global monetary system, even countries should be able to transact with each other without risk of having a transaction be arbitrarily reversed. Permissionless. Bitcoin is designed with game theory in mind. So miners, the people who process the transactions in the Bitcoin network, are aligned with picking the highest bidder, which makes permissionless aligned with the party who's trying to optimize their own profit. Permissionless is a must in a system like this, since you wouldn't want to rely on third parties for engagement with the system, especially if you're a government or the like. Okay, so how does Bitcoin work? Although I've only been using the word Bitcoin to refer to the currency, Bitcoin actually refers to two things: the currency and the network. To explain how the network operates, I'll go over three distinct actors in the Bitcoin ecosystem: hodlers, nodes, and miners. I was going to use the term economic participants, which is why it's in the parentheses, but hodlers rolls off the tongue a little easier, doesn't it? Hodler, as opposed to economic participant. Yeah, I think you hear it. Plus, the word hodler has a lot of mimetic energy in the Bitcoin space. And what is Bitcoin without memes? Not as fun, if you ask me. All right, now let's get into our first actor: economic participants. I define hodlers as the people who hold Bitcoin on chain. This group is said to have non-custodial Bitcoin, which means they don't trust someone else to manage the ownership of their Bitcoin. Some of these hodlers are regular people like you and me, and some of these hodlers are companies that custody Bitcoin for other people, like the Bitcoin exchange River. Hodlers use programs called wallets to make and broadcast transactions to the network. While some wallets are custodial, many allow you to hold your own keys, which we'll get into a little bit later. Nodes. Nodes are the programs responsible for downloading and validating the blockchain, as well as propagating other people's transactions. When participants transact, their transaction will eventually get broadcast to a node that will track and accept the transaction in an area called the mempool until miners are ready to process their transaction. The process of nodes finding each other is done by hard coding domains of prominent Bitcoin core developers into the code base and requesting information about random nodes on the network. Alternatively, Bitcoin core nodes can be configured to talk to a user-specified subset of nodes, so you don't have to rely on any DNS seeds if you so choose. Miners. In the beginning, there was nothing. No one had any Bitcoin to their name, not even Satoshi Nakamoto himself. The only way for anyone to ever claim any Bitcoin was to initiate a process called mining that pits computers against each other in a competition to solve a computational puzzle. The puzzle requires the miner to gather pending transactions into a collection called a block and hash the block with an adjustable field called a nonce until the output hash, which is interpreted as a number, is lower than another number called the target, which was initially hard-coded to bootstrap the network. Once a nonce that generates a hash below the target is found, the block is propagated to each node in the network, and if validation succeeds, is then added to each of their ledgers. All right, let's zoom out and think about how we can start engaging with Bitcoin from each perspective. Hodlers making a transaction. As we mentioned earlier, wallets are used to craft transactions, but they're also used to generate identifiers for wallet users so that other users can send them money. These identifiers are called addresses. For any hodler to send money, they need a recipient-provided address to send money to. If we're referring to other money transfer apps like Cash App or Venmo, this would be like a cash tag or a username. Now, once they type in an amount and destination address generated from the recipient's wallet and hit send, the transaction eventually gets sent to a node and goes into a pending state that we call unconfirmed. Nodes receiving a transaction. Once a transaction is received by a node, the node must validate the transaction is correct before accepting it as unconfirmed. A transaction must be valid before it's placed in the mempool and deemed unconfirmed. Transaction validation includes, but is not limited to, making sure the sender's address has enough money to send the specified amount to the recipient, verifying the digital signature provided on the transaction is correct and was made by the secret value, aka the private key, associated with the address's public key, and checking the fee attached to the transaction is above some minimum threshold. Miners mining a transaction. Those entities which we assign the role miners to will typically have specialized computers called ASICs, which they'll run along with a node. Since transactions typically require fees to be accepted and shared by a node, although a fee is not necessary in a protocol sense, and because miners can only fit so many transactions in a block to be processed at once, the time it takes a transaction to get included in a block is related to the fee placed on the transaction. Miners use transaction selection algorithms to pick transactions from the mempool that maximize their profit and fees. After collecting the transactions they'd like to process in a block, they then go through a process called mining, where computers hash the block data with a changeable value called the nonce until one reaches a hash value below a dynamically moving target. Once a target hash is found, the miner who found the nonce associated with that block hash is given Bitcoin from the unissued reserve that started at 21 million. All transactions within a mined block are said to be confirmed and have one confirmation when they are the latest block in the blockchain. Once another block comes in, the transactions in the second to last block are now said to have two confirmations, and this terminology holds with all the blocks that come after. If a transaction is in the third to last block, it has three confirmations. If it's the fourth to last block, it has four confirmations, etc. Recipient receiving Bitcoin. A recipient should not consider Bitcoin received until it has been mined in a block. This is because blocks can be reversed if a competing block at that specific height in the blockchain is mined with more work being defined as hashing operations here. There is a probabilistically determined amount of work that goes into mining every block, and if someone wanted to reverse a block, they have to expend just as much energy as it took to mine it. If a transaction is unconfirmed, it has not entered a block, and no miner has put in the appropriate work to give it a sense of finality. Therefore, it can be easily reversed. And in the Bitcoin world, this process of reversing an unconfirmed transaction is referred to as RBFing a transaction, RBF being an acronym that stands for replaced by fee. Difficulty adjustments. One of the most fascinating things in Bitcoin's design is a mechanic known as the difficulty adjustment. When miners mine blocks too quickly, the lottery to mine a block gets tougher, which is key to Bitcoin's design. As compute rises, the only way to ensure that the newest blocks have the same level of security with respect to reversal resistance as old blocks when they were mined is to require a level of energy proportionate to the amount of active compute on the network. This difficulty adjustment mechanism relies on timestamps placed on blocks to record the time. When what should be 2 weeks worth of blocks has been mined, which is 2016 blocks, the timestamps of the first and last blocks in that period are used to calculate the actual duration of that time, and the difficulty goes up if it turns out the timestamp calculated duration was less than the 2 weeks that were desired from the protocol. And vice versa, if the duration was longer than 2 weeks, then the difficulty lowers because you want to have a 10-minute average between block times, which would cause 2016 blocks to get mined in those 2 weeks. UTXO. Any video explaining Bitcoin basics would be remiss if they didn't explain what this very common and very cryptic looking acronym means. The blockchain doesn't keep track of your balance, it keeps track of each payment made to an address. Your wallet keeps track of your balance by adding these payments up into a single value. The phrase UTXO, pronounced as letters, stands for unspent transaction output and is a payment previously sent to you that can now be spent by you. The AC in transaction kind of makes an X sound, transaction, which is where that X comes from. Think of a UTXO like a chunk of gold and an address as a lockbox to which you hold the key to. To see your balance, go through all your lockboxes and sum the weight of the gold in them. Hopefully that analogy makes it easier to conceptualize how this works. Using the gold and lockbox analogy, when you send gold, you need to open the lockbox and remove the entire piece of gold to spend it. If the piece is too big for you to want to spend, you do the equivalent of chipping off the piece you want to send and keep the rest for yourself as change. The change is usually sent to a new lockbox/address so that someone watching the account of this happened on the ledger doesn't know which lockbox was the payment and which lockbox was the change. And that's a wrap for Module 101. This is all the information I had to give you, and hopefully this gives you a good understanding of the basics. Okay, everyone, I'm glad you made it to Module 2, Bitcoin tooling. And the first thing that I'm going to talk about is wallets. Entering the Bitcoin scene, I feel like there are a lot of confusing concepts that you have to go and learn and grasp. And one of those concepts are wallets. Wallets are programs that allow you to send and receive Bitcoin. Just like a paper wallet, you put cash in there and you can receive cash and put it in there and you can take cash from it and spend to somebody else. A Bitcoin wallet is just like that. When starting a wallet for the first time, most will force you into saving 12 secret words known as a seed phrase. So if you ever have created a wallet in the past, or if you create a wallet in the future, you will be using an application that will give you 12 words at the beginning. It tells you to keep it super, super secret and to write it down in a secure place. And that is because this seed phrase is vital to being able to spend your money. And if somebody else is able to steal that seed phrase, they can steal all of the Bitcoin that exists within your wallet. A seed phrase is used to generate key pairs that are used to both receive and spend Bitcoin. Every time you'd like to receive Bitcoin, a new key pair is generated, and the public key is used to create a random looking piece of text called an address. So when I'm actually sending Bitcoin to another individual, they will have a wallet on hand as well, and they can select receive on that wallet and have an address generated so that I can send them some Bitcoin. Okay, addresses are used as identifiers. So that address will belong to the person who generated it, and any Bitcoin sent to that address can only be spent by that individual. And that works because to spend Bitcoin received to an address, the private key corresponding to the key pair used to make the address must be used. So there's no way of getting around that. Keys define everything. Here's an example of a seed phrase. I have some words, 12 words, and this is exactly like how a wallet would give you a seed phrase for your Bitcoin wallet or to secure your funds. So spending conditions and identifiers. Bitcoin is usually locked behind a spending condition requiring a signature from one of its private keys. There are other ways you can specify spending conditions with code in a Bitcoin scripting language called script, but I won't go too much into that in this course. There's a lot more complexity surrounding script in the Bitcoin ecosystem. And once you delve a little bit more into protocol development and how that works, it becomes increasingly important. But again, this course is going to be focused just on Bitcoin integrated application development. So I will not be going too deep into the Bitcoin protocol. Private keys are generated from the seed phrases most wallets give out, which is why it's imperative that it is kept secret. And I've said this before, in the last slide, that it is essential that the seed phrase maintains its secrecy. You don't want anyone seeing it. You don't want your funds to be stolen. Even if you get a customer support call from Coinbase or River or wherever asking you to give your seed phrase to enable some support, just know it's a scam because no exchange will ever ask you for your seed phrase. And as I said before, private keys are generated from the seed phrases most wallets give out, which is why it's imperative that it's kept secret. And the generation process goes from seed to private key to public key to address. And this seed is capable of generating multiple different private keys and public keys, which are what we call key pairs. And each key pair can have a corresponding address that will be assigned to it, corresponding to whatever the public key is for that key pair. The specification for converting the seed phrase to a seed and a seed to a private key is in BIP39 and BIP32 respectively. So the seed phrase, there is a way to convert it into another piece of data called your seed. So the words are kind of the method of how you can assemble your seed. So there is another step. It's seed phrase, seed, then private key, then public key, then address. Addresses are derived from the public keys specified in the spending condition of a Bitcoin transaction. So when my wallet sends Bitcoin to a recipient, it generates a transaction. And I'm locking funds in the blockchain with and inside my transaction. And the condition that I will lock the Bitcoin on is going to include information related to the public key of the recipient, which was contained within that address that they gave me. Descriptors. Most consumer wallets follow the practice of showing the user a seed phrase to back up their wallet, but seed phrases are not used by Bitcoin Core. This is a little confusing for some people. You go and set up your wallet and you get a seed phrase, but seed phrases are not a standard that Bitcoin Core wanted to go with. It is something that is an industry standard for wallets, but the Bitcoin Core wallet uses a different mechanism. Instead of using seed phrases specified in BIP39, the Bitcoin Core wallet uses something called wallet descriptors, first specified as output descriptors in BIP380. Wallet descriptors are strings that can be used to specify keys used in a human-readable format, using the full hex value of the master keys and information on how to generate the additional child keys. So wallet descriptors are another way to be able to specify keys that can be used to generate other keys, or likewise a seed. Wallet considerations. There are a lot of different things you can consider when selecting a Bitcoin wallet. I will present a few considerations to you so that when you pick a Bitcoin wallet to use, let's say to generate addresses that you will put in some static website to receive donations, you will understand more about which wallet would be optimal for your use case and just you as a sovereign private individual. So the first consideration is custodial versus non-custodial. Custodial wallets are those where you don't own a seed phrase or keys and you trust the company to receive Bitcoin on your behalf. Think of custodial wallet companies like banks without all the same jurisdictional regulation. That's the best way to explain what a custodial wallet is. It is a company that is holding your money for you, sort of like FTX. Now, FTX is obviously a horrible example for a custodial wallet provider. And most custodial wallets, I imagine, operating internationally because the US has very hard regulation for custodial wallets that operate within the US borders. But if you use a custodial wallet like Wallet of Satoshi, most likely you'll be safe. But there's always going to be this counterparty risk where the people who are holding your Bitcoin can spend it without you knowing. And that is the problem with custodial wallets. Non-custodial wallets let you own your seed phrase and keys or wallet descriptors, because I did mention that in the last slide. And holding your keys allows you to craft transactions that interact directly with the Bitcoin blockchain. So you don't need any intermediary to go and move your Bitcoin funds. A custodial setup is how most people would use a stock broker to purchase their stocks. And there's not really a way for you to keep your stocks on hand. And if the company were to go bankrupt or some malfeasance was found within their operations, there could be a way for you to lose those stocks. But I don't know if there's an alternative for holding stocks without an intermediary. So that's just my limitation of knowledge. So you can think of a non-custodial wallet like a traditional one that holds cash. If there's a wallet in your pocket, no one can go and spend that money because it's on you. And typically assets that you can hold by yourself without an intermediary are called bearer assets. So if you want to be able to take Bitcoin's benefit of being a bearer asset to the fullest, then you will have a non-custodial wallet. Now there are benefits and disadvantages to having either or. For example, if you hold your own keys, you have to make sure you don't lose those keys. With a custodial solution, you might have customer support at that company. They're holding the keys for you and they have you ID'd, your KYC, social security and everything. And there may be a way for you to prove that you are who you say you are through the forms of identification you have with the government to this company. Whereas if you were to lose your Bitcoin keys, there is really nothing you can do to go and claim that money back. So it all kind of depends on your profile as an individual and what would work best for you. Another consideration is closed source versus open source. Closed source wallets are wallets that don't make their source code public, while open source wallets do. Since Bitcoin is a bearer asset, again, meaning there doesn't need to be a middleman holding your Bitcoin, many wallet developers open source their code base to allow other developers in the Bitcoin community to verify the software maintains that quality. So again, closed source and open source is whether a company that develops a wallet would like to have their code out in the open. What you get from that as a company that creates a wallet is the ability for all of your users to go and look at your code and make sure that you're fully non-custodial if you claim that is what you are. It's being able to give them the ability to audit if they so choose. Hardware wallets. Hardware wallets are devices loaded with software that understands how to sign Bitcoin transactions. They were made to counter the risk of an everyday computer that stores Bitcoin keys from getting hacked. The firmware on these devices are made such that extracting the keys from the device using any medium besides the screen is nigh impossible. Hardware wallets are devices that you might have in a safe at home or somewhere else secure. And these hardware wallets contain your keys on them. And whenever you need to sign a transaction, all of the transaction signing happens on this device. People prefer hardware wallets over computers because computers are used for so many things. I mean, if you're talking a general computer like Apple MacBook or Windows Surface Pro or just general computers, they're used to surf the web. They're used to watch and download movies and music. And there's a lot of things that can go wrong when you use your computer. I'm talking about viruses, Trojan horses, all of these bad things that can happen. And using a hardware wallet is a way that you can avoid this risk because this device is only used for one thing and its software is literally tailored to never give out your keys and to only sign or generate signatures, which is a zero knowledge proof that you had your keys to be able to perform an operation at some time in the past. So where do wallets usually get their information from? They get them from backend APIs connected to nodes, or they'll get them from public block explorers. Block explorers. Now, one way to get information about the blockchain without running a node is by using web services that provide blockchain information. Websites that provide information about the blockchain are referred to as block explorers. Block explorers usually allow you to query information about addresses, transactions, pending and confirmed, and blocks. Two of the most popular Bitcoin block explorers are mempool.space and blockstream.info. Mempool.space. This block explorer features a beautiful UI and is 100% open source. It provides the most comprehensive view of the mempool out of any block explorer, I would say. Transactions, addresses, and blocks are all viewable. Heuristics are used to perform analyses and provide more information about the context transactions were made within. See mempool goggles, and it just looks really cool. I have a little picture here in the slides. You can appreciate the visuals here right now. And the other block explorer that I mentioned is blockstream.info. Blockstream.info is also open source, has information about transactions, addresses, and blocks as well. And really, I would just say it's an alternative to use over mempool.space. And I say if you're going to use block explorers instead of a node, it's good to source your information from different companies. Again, to try and limit this idea of counterparty risk, which you can even get within your wallet. If the people who create your wallet make it closed source and opaque enough for other people to not want to audit it, or if the wallet is custodial. Privacy considerations. It's important to think about privacy when determining which Bitcoin tools to use. One thing that people don't get about Bitcoin is that it is not anonymous. There are ways to use it pseudonymously and increase one's privacy, but proper precautions must be taken. I'll briefly touch on two ways to improve your privacy by avoiding address reuse and IP leakage. And just to reiterate before I go to the next slide, I really want to get into people's heads that Bitcoin is not anonymous. There are ways to identify you, and if you buy Bitcoin off an exchange and withdraw it to your wallet and send it to somebody else, most likely the exchange is going to be able to identify that you, whatever name you have associated with your account at that exchange, have paid a particular address to another individual. And maybe they have that other address of that other individual because they also withdrew from Coinbase, in which case now they know that you sent Bitcoin to this other individual who they have all the information of. And through that, you kind of lose some financial privacy. There are ways to counteract this, but it's beyond the scope of this course. But I do think it's still important to at least mention it and let people know before they engage in their financial exhibitionism by accident. Address reuse. When someone uses the same address whenever they receive Bitcoin, we call this address reuse. People generally don't want any rando who owes them money to be able to see their Bitcoin balance by looking up their address. From the beginning, Bitcoin wallets were made to generate a new address for every payment they receive. Although they can't stop you from giving out the same address multiple times, wallets typically tend to push you towards the route of using different addresses when receiving Bitcoin. This way, a new sender can't tell how much money the recipient has. So if you keep using the same address over and over, then whenever you receive money, I can keep checking that address and keeping track of how much Bitcoin you have, which is a huge invasion of privacy. Imagine if in real life, if I wanted to pay somebody in cash and I bring my wallet out, there was a way for me to see all of their money as the recipient. That would be crazy, wouldn't it? I guess it's almost like me giving them money and them keeping their wallet open like this for me to see all of their other bills. It's just not good from a privacy standpoint. IP leakage. Whenever you access a block explorer using a browser, the block explorer has the ability to log your IP address along with your request for an address. So if you're on a block explorer and you're like, oh, Prem just sent me money, and you go to the block explorer and you put an address in, then that company that runs that block explorer theoretically has a way to go and bind your IP address with the address that you just typed in and save that. If a malicious party were to ever take control of the block explorer to target high net worth individuals, this information could greatly assist them in finding the locations of these individuals. So if an evil person went and took control of mempool.space or blockstream.info and they wanted to target certain individuals and they needed to tie location information to high net worth addresses, then this would be a treasure trove for that. Now, when you run your own node, which I'll be touching on in the next section, you can use the wallet that comes with Bitcoin Core to utilize an entire blockchain worth of data to find your funds without your node needing to selectively ask for your funds from anyone else. If you have a full node, you've downloaded the entire blockchain, and you should be able to identify your funds within all of the data that you've downloaded. So in this way, you kind of have privacy through obfuscation of your own local queries. You ask for the entire blockchain, which is a lot more than you need. And when you do that, other people really don't know your intentions as someone who runs a Bitcoin node and is just their peer. They just think maybe you want to run a node to support the infrastructure of the network. And even if they did think that you had funds, they wouldn't know which pieces of information are relevant to you, because all of your queries are done locally because you were able to download the whole database and keep it on your own computer. So no outside internet traffic to anyone ever needs to happen for specifically the funds at your address. And I kind of reiterate that in this last point. When you run your own node, which I'll be touching on in the next section, you can use the wallet that comes with Bitcoin Core to utilize an entire blockchain worth of data to find your funds without your node needing to selectively ask for your funds from anyone. Finally, let's jump into a project, because what is this course if not application development? So the first one's gonna be a very simple project where you're gonna have a static website that will just have an address and an address QR code to accept donations from. Okay, so since I said we're gonna focus on making a static website with a Bitcoin address, I think the first step to starting to do that is to download a wallet from online. I'm probably just gonna stick with the Blue wallet because it's one of the wallets that I started out with. There are other wallets with different levels of security to them, but Blue has always had a special place in my heart. So let's try them out. They're pretty easy to find. You could go to Blue Wallet and it'll probably be the first result. They also have a GitHub page. And what I tell people, what might be good for them is to navigate to a GitHub page like this one, where they see it has a lot of stars, forks, and eyes watching, because these GitHub pages and the stars that they're given typically have some rapport to them. So any links that are associated with this page or that are on this page should have some more authority to it than a random link that you find on Google, especially because there was a time a while back where Google used to have malicious links they used to post on their search results. And you would think that it's a real wallet, but it would be a fake one. And you download it and it seemingly does everything that a wallet does. But when you create an address, it actually creates an address of some scammer who made that fake wallet, instead of from deriving the address from the keys that are on your device. So this is just another level of verification maybe that you can go through before downloading a wallet. So just click this. This is going to be the same as what we found from Google. And here you can see that there's a direct download available for Android and desktop. Let's just go to desktop, download for Mac OS, and we can download it on the Apple Store, so why not? Okay, so it opened here in my App Store application, and I'm just going to press open since I guess it was installed. And this is how it looks. We have opened our wallet, and we have no transactions, and we have no wallets. So let's just click add now, and it gives us options. We're just going to do regular type Bitcoin, and I wonder if we could just click create, take the default name. Yeah, cool. So this is a seed phrase. I briefly went over this. This information is very important. Anyone who is able to access this information can take all the funds that you end up having sent to your wallet. So you really need to take care to not lose this information. And I know you might be tempted to say, okay, I wrote it down, but a lot of these wallets will not just let you lie because they'll quiz you on whether you actually recorded the seed phrase. So let's try that out. Okay, I wrote it down. Oh, well, luckily this didn't quiz me. And to retrieve an address, I could just click on receive. Have you saved your wallet's backup phrase? This backup phrase is required to access your funds in case you lose the device. Without the backup phrase, your funds will be permanently lost. Let's just say, yes, I have. Would you like to receive notifications when you get incoming payments? Sure, awesome. Okay, so now we're able to get an address. I just clicked on it and it says copied to clipboard. There's also a QR code that contains the text data of this address. And now let's just try and make a simple static website that people can navigate to and see our address with a QR code. And this project is going to be very similar to one that we're going to make later on called the Bitcoin donation tracker. This is just kind of a preview or maybe a build up to what we're going to be doing at the end. Okay, so this part is going to be very bare bones. I'm not going to have any CSS. It's going to be straight HTML. So let's do this. HTML. I'm going to put a head tag here. I'm going to put a body tag here. Let me format. Okay, so not much in here, and there won't be much when I'm done, to be honest. And in this H1, I'm just going to say, hello, everyone. Please donate to my address. And I'm going to make a paragraph tag here. It's just going to say address. And what I hope to have is an address that will go within here. And it would also be nice if I had a div tag. Let's just make its ID QR and have the QR code right below it. So that will be our intention. This is how it looks now. Like I said, very bare bones. And another thing that I'll mention here, and I'll keep mentioning because I want it to be known, that no one, absolutely no one, should send money to any of the addresses that I have in this video. They're all test addresses. And in this example, I even show you the seed phrase that's used to generate the address, which means that anyone who sends money to the address that I end up putting on this page can have their money taken by anyone who watches the video and sets up a wallet with the same seed phrase. So we should still have the address that was copied to our clipboard. So let me just paste it in here and save. And if we refresh, we see an address. And this is how easy it is to make an HTML page that contains an address that we can now send money to. Oh, it's pretty crazy. Now for the QR code. I actually go over how to make QR codes in a later section of this course, but I'll show it now as well because we need the functionality. And I know some people might skip around the video and won't watch every single part. So it's probably best that I do it this way. Anyway, navigate to Google and you can put in the search bar something like QR code JS. You can do a Google search and you will see a page, qrcode.js. Click on it. Now this page offers you a .zip file, so click on that. And it is that easy to download a version of qrcode.js. And within this folder, after you unzip it, you should see a qrcode.min.js. I have my own folder for where I have the static website that contains our address. It's called static Bitcoin donation tracker. I just want you to paste that file, qrcode.min.js, in the same directory. And trust me, this will be easier than you know. Going back to the qrcode.js website, you can see examples of how to use this library. And as you can see, it is not very hard. Let's look at this example. just says new QR code. It specifies an element on the HTML page, and it includes the text that it wants to encode within the QR code. Okay, so this is the usage. We have our ID called QR instead of QR code, so we will have to remove the code, but we could almost copy and paste this. Let's paste the script right before the end of our body tag, save our file, change this from QR code to QR, take our address and copy it to the clipboard again, paste it where this text data should go, and now we have everything set up to make the QR code, except for the fact that we did not include our QR code.js min file. So how do we do that? Well, let me tell you, it's not very hard. All we have to do is add another script tag before the one that we just made, because the QR code min file needs to be imported before we actually use QR code. And we just put source in here, and let's use / to represent the current directory, and we could put in qrcode.min.js here and save the file. It's also good to put in type equals text/JavaScript. It's just something that people do to declare the type of this file being included. And you even see it here that we copied over from the example. This, of course, did not need a source file because we explicitly wrote what we want to be in our script within these script tags. And let's save it again. We're going to re-render the page in Chrome. Let's refresh, and what do you know? We have a nice QR code and an address. Now that we have a basic site up, I thought, hey, why not extend the basic site a little bit more to give it an added piece of functionality that I think would be really cool. And while doing that, I could even showcase how to use a block explorer interactively, since I already explained a little bit of what it is and what it does, but now I can give you the full tour. So as I said before, you have blocks, and within blocks you have transactions. These are all the transactions within a block. Each transaction has a unique ID. And if you select details in this block explorer, you can get more details that I didn't really go over, so this might seem like gibberish to some. And what I really wanted to show you is something that I think is really cool. A common way for people to check the balance of their Bitcoin addresses without maybe opening their wallet is just by navigating to their address within a block explorer. So if you look at this transaction is something called a Coinbase transaction, which mints some of the Bitcoin from, let's just call it the system reserve, which can only contain 21 million Bitcoin. And when you select this address here, you'll see something interesting. We have confirmed received, confirmed spent, confirmed unspent. So this is all of the Bitcoin that this address has received. This is all of the Bitcoin this address has spent. And this is what should be left over. So the important thing I wanted to note is that you can see the balance of an address using the block explorer. So how can this help us with our application? Well, wouldn't it be cool maybe if we had some goal that we wanted to meet financially with our static donation site, and make it so that when anyone refreshes the page, they can see how close to our donation requirement we are. Well, luckily, these block explorers have APIs that are accessible for developers that will allow me to query for things like the amount of Bitcoin within an address. So let's go ahead and integrate that into our static site. So from this page, we can go into the menu here and look under Developer Tools and see API. Click on that, and it opens up to an API page. And it has an example of calling an API. So if we were to navigate to this page in our address bar, then we should be able to see information returned. And we do. Now, the information that I'm concerned with is the balance of an address. So let's go back here and look. Let's do a Command F for address. And perfect, we have a whole section on addresses. Now let's actually try to see what this would give us. So instead of blocks tip hash, let's start from API, and we're going to put address, and then colon address is a placeholder. So let's take in the address we navigated to with the UI, and look what we have here. We have some information. So we have the address, chain stats, funded transaction output count, funded transaction output sum, spent transaction outputs, spent transaction output sum, and the transaction count. We also have these things called mempool stats, which we do not need to look into. This should actually work for our purposes because we have two numbers that we need to calculate the balance within this address. One is the funded transaction output sum, and the other is a spent transaction output sum. And remember, when we look back at our Blockstream Explorer page, we see that the unspent amount is just the funded amount minus the spent amount. But one thing you might be wondering is why this has a decimal in it and why this API is showing an integer number. Well, as I've alluded to before, 1 Bitcoin actually has the denominations, like $1 has the denominations in 2 cents. 1 Bitcoin can be subdivided into 100 million Satoshis. So this is actually showing the Satoshi count. And if you were to take this number, let's open up our developer console to do some quick math. Oh, don't paste code in DevTools. Okay, well, I do understand. And it still doesn't want to let me paste it in, so let's just type it out. 1887483. And we're going to divide it by 100 million. And we get 0.01887483. So when we convert our number of Satoshis back into Bitcoin, we should get a decimal value like this one. And if we copy this value and go into this page with the address in it, we can see that it matches the confirmed spent. So really these values are equivalent. They're just using different units of Bitcoin. Okay, well, let's try and put in our own address that we made in Blue Wallet into the API URL and see what it gives us. It should give us 0 for everything since no one sent any money. So let's go here, copy this address, put it up here, and like we expected, 0 for everything. So how can we make a request to this API URL from our HTML page? Let's just copy this URL, and we're going to do something interesting here. So I'm going to make a new field, and it's going to be called, I don't know, what should I call it? Bitcoin donation goal. And in here, let's just say 1. And here, we're going to put Bitcoin received so far. And here's where we should put in the Bitcoin balance that we're able to retrieve from the API. And let's even put another field in here that says goal met. And let's put an ID in here that just says hidden. And I'm going to make some quick CSS stylings in the same HTML document that adds display none to our hidden element. Now let's refresh the page, see what we have. And this is what we have. We have our goal, and we have the Bitcoin that we received so far. And back here, we can just make a function that says get balance from block explorer. And the way that we can make HTTP requests from an index.html file in the browser is by using an API accessible to most browsers, which is called fetch. And within this fetch, we are going to add our URL to that API endpoint we want data from, which should be here. Okay, one thing we have to do is make this function async. It just makes everything easier because fetch is what we call an asynchronous function. What that means is if I put a console.log down here, hi, the execution environment during the invocation of this function will go through this fetch and say, hey, browser, go fetch this data asynchronously. And we're not going to wait for you to come back with the results of the API call. And it'll just go to console.log hi and then end. But what we want to do is we want to wait for the response to this fetch call and save it into a variable. Let's just call it RESP for response. Now, when we continue on in the next line, we can be sure that this response is populated with something. And let's make another variable called parsed. Let's just call it parsed. And we're going to take this response and convert it into JSON because it should be in JSON format, which is what they showed us when we navigated to this URL. And now comes the calculation of our balance. What is it again? It is funded transaction out sum minus the spent transaction out sum. So we're going to take funded transaction out sum. Actually, we can destructure this object and make it equal to parsed. And just to check if it works, let's console.log funded minus spent. Save. Let's invoke this, or else we won't see anything, and save it. Now if we navigate back to our index.html file, open up our console, and refresh, we got a value, not a number. So some quick debugging will allow us to see what went wrong. You can just type in debugger down here. When we refresh, we can actually view these variables, and I see what's wrong. When we parse the response, it's also an asynchronous function. So we were executing this before this finished, which means that these would never be contained within this variable. This variable contains a promise of a value, not the actual value. So let's just type in await here, delete the debugger statement, go to our console, refresh, and it looks like I may have missed something. Funded transaction output count and sum and count and sum here is within chain stats. So I should actually do .chain stats here. Now if I refresh, we get 0. Now to check if this actually works, let's use another address. Let's use this address that we know has a balance in it and has both a received and spent balance. If we paste it in here and save, go back to our index.html file and refresh, we do see 5842073, which is not the correct sum. So let's see why that is. I see what we did wrong. This count should be sum. Let's refresh, and now we get 3954598, as we see here. Now I think it's useful to run into common problems and bugs, just because I know whoever's going to be following this guide will run into these common problems and bugs. And if you don't care for these, you can just look at the code on the GitHub repo. But as this course is about developing Bitcoin integrated applications, I also think it's important to show some of the tools that I may use for debugging. Okay, so now that we can get the balance and we know that it's the correct balance, we could change our address back. And we can populate this Bitcoin received so far. So I'm gonna give it an ID, I'm gonna call it received, and I will try and speed through this next part. Just remove this console.log and just make a variable called balance. And remember, this balance is in Satoshis. So I can put balance in sats, which is how we like to abbreviate Satoshis. And I can make another variable called balance in Bitcoin. And I can take the balance in sats and divide it by 100 million. And let's add some comments just to make this even clearer. Make request to Blockstream Explorer, calculate balance, now we're gonna display our balance. You can do document.getElement by ID, get the received element, let's call it the received element. And all we're going to do is the received element dot inner HTML is equal to what's already there plus our balance in Bitcoin. And let's save this and refresh and see if this gives us our desired result. And we do get a 0, no space here. And I do want a space, so let's just add it there. and we get a 0. Now for this message, goal met. Let's add another section, display goal met. And this is just given the idea of hidden. And I'm thinking, how about we make this an H1 or an H2, since we already have an H1 at the top header, because it's something important, big, that we want to stand out in our application. And instead of hidden, let's just call this goal. And I'm going to put goal here. So we're going to do something very similar. Well, first, we know what our goal is, which is 1 Bitcoin. So let's just hard code what our goal is at the top of this function. Goal in Bitcoin is going to be 1. And because I don't ever want to change this value and not have this value change, I'm going to dynamically add this goal in Bitcoin to this HTML element. So let's call this, now we have a naming conflict, goal, and we'll call this goal met. So let's just display the goal. We can copy and paste this. It's going to be very similar code. This is going to be goal element. We're going to replace this with goal for the ID. We're going to replace the received element here. And instead of including the balance in Bitcoin, we are going to display our goal here. Goal in Bitcoin. Let's save just to make sure everything is still working as expected. Perfect. And now we can display the goal met message if we were actually able to make our goal. So let's just make an if statement, and we're going to test if our balance in Bitcoin is greater than or equal to our goal in Bitcoin. Then what we'll do is we're going to copy and paste this. This should always be indented. And I have Prettier, which is a formatter in Visual Studio Code, because I don't like formatting manually, which is why you'll see I do this command pretty frequently. But yeah, we have goal element. So this shouldn't be goal element anymore. It should be goal met. This should be goal met as well. And this should be goal met. And we're not going to change anything with the inner HTML. All we're going to change is the style of this element. So we're going to go to style and display. And let's just type in block. Let's format it. And nothing should really change, which is unfortunate because we can't test with the 0 balance. But what we can do is use this address again. And since it has 0.039 blah, blah, blah Bitcoin, let's make our goal under this just to make sure everything works. Let's make it 0.001. And we're going to use this address to test. So I'm going to put this address in this fetch call. I'm going to make our goal 001. I'm going to save it. And then I'm going to test that if we have met our goal, it'll show us the message. Just refresh. Goal met. Awesome. Maybe some other good test cases is to test the exact number. Goal met. Cool. Let's make this 1 Satoshi bigger. And the goal isn't met. Okay. So it looks like things are working fine. So if we put our address back here, we should have everything as it was. Anyway, that's all I have for this section. Thanks for tuning in and staying with me, watching me program, and hopefully learning from my mistakes, the way I debug, and how I navigated to the documentation of a block explorer that can be easily used by anyone for their application. To an extent, at least. This is a free service with limited production guarantees. So if you actually wanted to use this for a more powerful application, the recommendation would be to set up some upgraded offering with the company Blockstream, which I work for, by the way, so full disclosure. And that wraps up this section. So I recommend that you go take a break, play around with what I just showed you, because the next section is going to be kind of long and you're going to need to strap it a bit. Thanks for watching. Bitcoin nodes. And in this module, I'm going to teach you everything that you need to know about Bitcoin nodes, at least from the perspective of an application developer trying to integrate Bitcoin. So the first question, what is a Bitcoin node? A Bitcoin node refers to a program that's responsible for downloading the entire history of the Bitcoin blockchain, including its transactions, and it keeps track of the Bitcoin that's still spendable. Now, the natural question to ask next is, what do Bitcoin nodes actually do? So that I would say Bitcoin nodes broadcast and relay transactions. They validate blocks and the transactions within them. They share information among peers, and they maintain the utxos set. So they have quite the responsibility with respect to the network health and the functioning of Bitcoin as a whole. And I cannot stress this enough. Nodes are essential to Bitcoin's functioning. Without nodes, there is nothing. Why run a node over using a block explorer? So a lot of wallets and other applications, they decide to use a block explorer instead of a Bitcoin node to pull information about the blockchain. Now, we even used a block explorer in the last module. So why do we even need a Bitcoin node? Well, so here's why you should run a node over using a block explorer. A block explorer can provide information about any block, transaction, and address. But unless the entire chain's history is validated against the proof of work on every block header, the information is only as reliable as the party providing it. It may not be reliable, it may be reliable, it depends on your trust in the company that is giving you the service, either for free or by contract. So Bitcoin was made with the idea of transparency for all, and a block explorer requires trust that they are not lying to you with respect to the balance owed by a given address. When you run a Bitcoin node, it validates unspent Bitcoin balances, all came from a blockchain consistent with the consensus rules and from a chain with the most work. So you can't really forge work. The main chain has the work that all the miners are contributing, hashing every second. And if you have a false chain, you could detect that pretty quickly with the Bitcoin node. But with the block explorer, you're trusting whoever runs that service to have a node in the background to validate that proof of work on their best chain. And I have an analogy here of what it's like running a block explorer as opposed to a Bitcoin node. Only using block explorers instead of running a node is like trusting an employer to put money in your bank account rather than looking for yourself. So it might be okay if you trust your employer, but it's always best to check that they're following the rules yourself, right? A lot of people are very distrustful, and maybe they have a right to be, but verifying for yourself has no replacement. So why run a node over using SPV proofs? In the white paper, simplified payment verification, also called SPV, is a way to verify your transaction belongs in a block and that a certain level of hash power went into mining that block. SPV works by having a program called an SPV client download every block header since the Genesis block, then requesting inclusion proofs that a given transaction sending to some destination address was included in one of those block headers. The problem with this approach is the transactions within those block headers aren't given to the SPV clients, and the provider of such data could be lying to them about those block headers being valid blocks, which could help fake information about a payment being received. SPV proofs are fine if you need to validate a payment on a prune node, but maybe they're not fine if you have no information about the blockchain outside of the SPV inclusion proof or the block headers. Now, the analogy here for SPV proofs is that SPV proofs are almost like the last analogy where your boss tells you they deposited money in your account, but this time they give you a little more proof. Let's say they give you a screenshot of your paycheck from the payroll software and a signature from the head of HR saying you got paid. It's still lacking the guarantees of just checking for yourself, but it's a lot better than the Block Explorer example. Now, theoretically, if you had your own Bitcoin full node, you can validate the block headers that you got from your SPV client and the inclusion proof to make sure that your Bitcoin node that is verifying things has all information that it needs, especially if you have a prune node, which means you've deleted past transaction data in favor of saving storage for just the unspent Bitcoin transactions. All right, for this section, I'm going to be showing you how to run a Bitcoin node. Running a Bitcoin node is one of the biggest benefits of using Bitcoin over other cryptocurrencies because being self-sovereign is prioritized in the Bitcoin space, and it isn't in a lot of these other cryptocurrencies. To run your own Bitcoin node, I'm going to suggest a software called Docker, so it'll be easy for me to guide you through running your own node on your own machine. Docker is a way to package up software in something called an image, which Docker defines as a lightweight, standalone, executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, and settings. Basically, it's a way to make sure what I'm doing will work on your computers as long as you're able to install Docker. So the first step is downloading a node. First, we need to download the Bitcoin Core software. If you navigate to bitcoincore.org, we'll be able to download the Bitcoin Core software, but I have a Docker file that does all of this for you, and you will just need to run this Docker file. So let me just show you how to do that, and we can follow along from there. So this is the Docker file that I will be using and that I have up on GitHub. The link should be down in the description. And let me walk through this Docker file very quickly. In this first step, I'm going to be basing my Docker image on an Ubuntu Linux image. I'm going to set my current directory to /app, which is a folder in my root directory it'll make for me. And then I'm going to run apt-get update-y. This is just going to update a package manager that comes with Ubuntu. Next, I'm going to run apt-get install curl-y. And this will download curl, which is a tool that will let me download the Bitcoin Core software from the internet. Now I'm going to download the Bitcoin software from the internet by calling curl-o, the link to the Bitcoin binary that I would like to download. But really, it's not a binary. You're downloading the archive from the website. And then the line after that, I'm downloading another file called SHA-256 sums, which we'll see referenced in the Bitcoin Core website when we get back to it in a second. The next step, we're going to run SHA-256 sum, which is a way to verify the hash of the archive that we're downloading. This is a way to verify authenticity of our download and make sure it didn't get corrupted on the download. Finally, the second to last step will be calling tar-xvzf with the Bitcoin archive, and this is almost like unzipping it. This is just opening up the archive into its own folder with all the individual files and folders inside of that top level folder. Finally, we're going to run /bin/bash, which is a way for us to access this machine that I set up for us. Just so I can show you up close, why don't I make my own Docker container by just spinning up an Ubuntu image from the base and making all of these commands manually. And to do that, I can run the command docker run -it, which means interactive. And I can put -- platform equals Linux/AMD64, again for M1 resolution. And I'm going to put the base Docker image that I want to spin up, which is Ubuntu:22.04. And when I run this, it will put me in the root of my container. This is roughly equivalent to dropping me off at line 2 in the Docker file, except instead of the directory app, it'll put me in the root directory. Now I'm going to run the command on line 3, which is apt-get update, and I'm going to put in -y, so it will not prompt me to confirm whether I want this. And then I'm going to type in apt-get install curl-y. This will take a little bit, but it's going to download the program curl, which should download the Bitcoin archive from bitcoincore.org for us after it downloads, of course. Okay, so now we have curl, and we can put in what we have on line 5, which is curl -o, which means save this to a file, put the same name that it already has on the server, and then we can put the link, and it's downloading Bitcoin. Okay, that's quick. Now, what we want to do is download this verification file. And I'll talk about this a little bit after, but it's called SHA-256 sums. And now I'm going to use the verification file to verify the archive we just downloaded from bitcoincore.org. Okay, it says okay. That means everything's great. Now let's open this archive by typing in tar-xvzf and the name of the archive. And it should open. Now let's do ls. We can see this folder, Bitcoin-27.1. Now let's type in cd Bitcoin 27.1. We can cd into the binary folder. That's ls to see what's in there. And all we have to do from here is Bitcoin D, and this will start up our node. Easy, right? Now, the equivalent of what we're doing, I can show with these slides and the websites that I have on these slides. So first off, we download the Bitcoin Core software, and I already showed how to get to the binaries here. Now, the next thing we need to do is run the files in the package distributable, which we unpacked in the Docker example I just had. And I have this link and a QR code to explain more of the tar command that I used. And then finally, we'll verify the binary for authenticity as a final step before we run the software. If you go to bitcoincore.org and you go to that download page and you scroll to show version history in this box with the yellow border, you can see a whole bunch of versions of Bitcoin Core. But right on this previous page, you can keep scrolling down and you'll see in verify your download that there's a couple different links. And since we're running Linux with Docker, you can click on that Linux verification instructions. And in here, all I did was download this SHA-256 sums file, and I ran step 5, which is using SHA-256 sum. There's some more validation you could do here. Feel free to do this as an extracurricular, but I just did a very basic check for authenticity. All right, so now that we have our node, we can start it, which I showed you, and I have some more information here. The actual file used to start a node is named bitcoind, which is what we started. To run the file, we cd'd into the folder where it was downloaded and entered /bitcoind. And as soon as we ran that, it kicked off the download of the entire blockchain since the first block, which was published back in 2009. And finally, I typed Control-C to cancel the run because before you download the entire blockchain, there are a couple things I want to explain. One of the things I would like to explain are networks. The Bitcoin blockchain has multiple different networks deployed. Some network names you may have heard about before are mainnet, testnet, regtest, signet, and within the signet category, there's Inquisition and Mutiny, I think are probably some of the most popular. Now, depending on which configuration you choose, your node can connect to an entirely different blockchain that still follows most of the rules that Bitcoin does, but may have some slight variations. These networks are created for testing purposes, and the coins on these networks have no monetary value. Although throughout the history of Bitcoin, sometimes coins on this network get scarce, and we have this emergent property of value that appears. But to enforce this idea that these coins don't have value, a lot of the times, these test networks are just reset. One of the test networks that we'll be focusing on is regtest. We'll be using a network called regtest that stands for regression testing because it's probably the easiest network for us to use in the context of development. The regtest network we're going to make will start off as an empty blockchain that follows most of Bitcoin's rules with slight exceptions. To run a Bitcoin node in regtest, enter /bitcoind-regtest. All right, it can get a little bit annoying typing in regtest every single time you want to run bitcoind. So I want to introduce you to an alternative approach to using the -regtest, which is using the bitcoin.conf file. As I said, bitcoin.conf is another way that we can launch bitcoind in regtest without including the argument every time. And the bitcoin.conf file is located in a directory known as the data directory. which defaults to a specific place on your computer depending on your operating system. The bitcoin.conf file is read by bitcoind on startup and contains configuration values in the form of some key equals some value. To always default to write_test, let's add write_test equals 1 to the first line in our bitcoin.conf file. Again, just to sum it up, the bitcoin.conf file is the way that you could specify configuration values that you want bitcoind to pick up before it's actually executing. It's a very quick way to be able to save settings and share it across computers. The second thing I wanted to go over is the Bitcoin CLI and JSON RPC. The bitcoind binary has a companion application called Bitcoin CLI, which should be in the same unpacked folder. Bitcoin CLI communicates with bitcoind using the JSON RPC API that bitcoind exposes. JSON RPC is a protocol that applications can use to talk to other applications. One server service defines the methods that calling applications can execute, while a client service will send JSON data that specifies the method and params needed by the server to fulfill the desired method and request. It's a simple protocol that can be implemented within the same process over sockets, over HTTP, or in many various message passing environments. In bitcoind's case, it's transported over HTTP. Useful RPC commands to remember. So let's use some Bitcoin CLI commands. Some useful RPC commands to remember is get blockchain info, create wallet, get new address, send to address, get raw transaction, decode raw transaction, and -generate, which is an argument you can type in if you're using the regression testing network, write_test. Let's test out these commands on a write_test node using the Bitcoin CLI. So if we look here, I should be in this Docker container. I'm going to run bitcoind. Cool. Now we're running bitcoind. Now I'm going to show you a trick so that we can actually log into the same Docker container while it's running and call Bitcoin CLI. So first, let's type in docker ps. This will show us all of our running containers that we can log into and run additional commands from. Here we can see the container ID of the only container we have, and I'm going to execute this container in a separate shell. To do that, I can write docker exec -it, always for interactive, and I can put the container ID and then the application that I would like to launch, in this case, the shell. So now I have a bash instance into the same container. Now let me ls, make sure everything is here. It is. So now I'm going to cd into the Bitcoin folder, and I'm going to cd again into the binary directory. And here I see that we have the Bitcoin CLI application. So let's try and run it. I accidentally ran this on mainnet when I meant to run it on write_test. So let's actually change the bitcoin.conf file to only start up on write_test. To do that, let's look up where the data directory should be together. So if I type in data directory Bitcoin Core onto Google, you should see a link that looks like this from the bitcoin.it domain. And we can scroll down until we see our operating system. Since we are using a container on Docker that is Linux-based, this will be the relevant section. And it says that our data directory should be in our home directories .bitcoin folder. So let's look there. From here, I'm going to go in our home directory /.bitcoin. And sure enough, we do see a file here that's named, actually, we don't see a bitcoin.conf file here. So let's make one. I'm going to use a quick tool called vi bitcoin.conf. Hopefully it comes pre-installed. It doesn't. That's fine. We can use Ubuntu's package manager to install this text editor. Actually, let's install Vim. Okay, cool. Now it's installed. So I can just type in vim bitcoin.conf. And here, I simply have to type write_test equals 1, escape, and then I can press :WQ and enter. And this should save my bitcoin.conf file. Now, if I go back to my root directory, where I have this Bitcoin folder with the executables, I should be able to run bitcoin d, and it should automatically pick up the setting that I placed in the bitcoin.conf file and put us into write_test. The fact that we didn't load any addresses from the DNS seeds and that we're not downloading blocks, it seems like it all worked and we are on write_test. So now we can go into the Bitcoin CLI, which also looks into this Bitcoin data directory folder for the bitcoin.conf, so it can set its settings, and write a command. Let's try out the first command, get blockchain info. And we do see that we are on the regression test chain. We have 0 blocks in this chain, 0 block headers, a best block hash that doesn't correspond to any blocks that we've created, and some other data about the blockchain that we have here for regression testing. Let's look at another command that we have, create wallet. So you can also have a wallet attached to your Bitcoin node, and a way to create that wallet is using, as you can imagine, the term create wallet. And you could actually name your wallet here. So I'm going to name this first wallet. And now we have created our first wallet. Now that we have our first wallet, we can generate a new address for this wallet so we could receive funds from anyone who wants to send us Bitcoin. Of course, this is write_test, so we'll be mining all the Bitcoin on this chain ourselves, and we'll be sending money between different wallets if we want to test things out. So from here, I'm going to type out Bitcoin CLI get new address. And sure enough, we have this address. Now we can do send to address, but we don't have any Bitcoin. So let's skip all the way to the bottom where I have the -generate command. Now I'm going to generate 101 blocks on write_test and then check my balance. I have 50 Bitcoin. Basically, when I run Bitcoin CLI with the generate command, it generates the specified number of blocks. And I typed in 101 blocks because for every block, I'm receiving the Coinbase reward to the wallet that I have set up on my write_test node. And when you receive a Coinbase reward to an address, it's actually only spendable after 100 blocks. So it made sense for me to do 101 blocks so that I can have that first block spendable, which is why I have 50 Bitcoin in this write_test balance. Because in the beginning, there were 50 Bitcoin in this block reward, also called the subsidy. Okay, so now that we have some Bitcoin, let's try out send to address. /Bitcoin CLI send to address. And I'm going to pick this address that we generated up top, and the amount that I want to send to this address is 1 whole Bitcoin. Okay, now it's giving an error about there needing to be a fallback fee because the Bitcoin core node is unable to estimate what a fee should be, since all of these blocks have only had one transaction, which are the Coinbase transaction. So what we have to do here is close out this Bitcoin D running write_test and specify an argument of a fallback fee. So I think this should be okay if I put 1, 2, 3, 4, 5, 6, and then 1, 0. Now, if I try and send to an address, I have to load my wallet back up. Sure. To do that, you use a command called load wallet. And I'll put in first wallet here. Now that I have a wallet loaded up, let's send to the address. And it was able to send because we specified what a fallback fee should be for the Bitcoin Core node if it's unable to estimate it for itself. Another RPC command we can use is get raw transaction. Get raw transaction allows us to take any transaction ID, like the one that was generated when we use send to address, and transaction, and get the transaction hex. Now, there's arguments that you can put in that were optional. So if I type in true after I type in the transaction ID for get raw transaction, it will actually give me detailed information about the transaction instead of just the hex. And the detailed information comes in the form of JSON and includes information like the transaction ID, the hash, the version, the size, virtual size, the weight, and so on and so forth. But let's say I have the transaction hex, but for some reason, my Bitcoin node can't actually retrieve the transaction with get raw transaction. What I can do is I type out Bitcoin CLI decode raw transaction, and I could paste the entire hex for the transaction right after it and have Bitcoin CLI make a call to Bitcoin D to parse this hex into the JSON. And I think that completes all the RPC commands that we have listed here. So let's jump to the next section where we're going to call our Bitcoin D instance using a node.js application. Okay, so now we're going to start calling our node from our node.js application. But there's a couple things that we need to go over first. The first thing is how to tweak our Docker command to actually expose our Bitcoin node. Right now, our Bitcoin D program is siloed into a Docker container that has no access to host things on the port of our host machine. To allow the Docker container to host a program accessible from a port on our machine, we have to bind that port to one on the container. All right, now to do this, we'll add -p 18443:18443 to our Docker startup command. Now what this will do is it'll bind that first port from our machine, 18443, to the port within the Docker container, which is also going to be 18443. So I pretty much want to bubble up the port that's in the Docker container all the way up to our host machine. Now our Bitcoin D should be accessible from a computer with local IP 127.0.0.1, aka localhost, and the default port for reg test, which is 18443. Now let's go and try to run this command. So again, our Docker container right now does not have any access to our host ports. So if we make an application from our machine and we try and access a port that is open within the container to accept a request for an application, it just won't work. So we need to connect our Docker container to our ports, and this is how you do it. First up, we have to exit our Bitcoin node that's within the container, and now we're good. Let's exit Bitcoin D, exit. All right, so we can run almost the same exact command, except now what we'll type in is -p and exactly what I said before. So if you look here, it's just going to be 18443:18443. Now we could add it somewhere before we start the container as an argument, and it's going to be 18443:18443. It actually looks like my port 18443 is in use, so I'll actually use 18444 on my host machine. All right, quite a few of my ports were used, so I actually bound the Bitcoin D write test port that is going to be open in our container to my own port 8080. So on your computer, hopefully 18443 is available, but as you can see, a lot of my ports were taken for some inexplicable reason. All right, now we just do what we did before, and we are going to run Bitcoin D, but every single time you start your container, the data is actually reset. So what we need to do is look inside of our Bitcoin data directory. Okay, I forgot that I was doing things step by step. So now I'm actually going to run the Docker container that we made with all the commands pre-configured, because otherwise I'd have to run all those commands again. So to look at all the images I have available, I'm going to type in Docker images. And here we can see that there are 2 images. I'm not sure if any of these are the image that I want, so I'm going to build from this Docker file by typing in Docker build. And since this Docker file should just be in the same directory, I can just put a dot to reference that this is the directory you should look for my Docker file in, and I can name it with -t, and I'm going to call it Bitcoin-dev. Now my Docker image is going to be built. It's installing everything I did manually in that last step. Bear with me for a moment. Whoops, one mistake in our Docker file. Let me correct that. Cool. Everything's all said and done. Everything works, seemingly. So now I'm going to run docker run -it. Let me bind the correct ports, 8080, since that's what I have available, and then 18443. Then I'm going to type just my container name, which is Bitcoin-dev. And hopefully this works. There we go. Now I have to go and change my bitcoin.conf file to be configured to reg test. So let me do that now. The data directory is made on startup of Bitcoin D. So I'm going to start it once up just so we can have that folder there again, because when you run your container or when you shut down a container, all the data of that container is lost with it. And that's use something called the Docker volume. But because we didn't, I have to reconfigure our bitcoin.conf. So I'm going to go here and run Bitcoin D under reg test just to make this data directory. I'm going to close out of here. Hopefully this data directory has been made. And there it is. Now we can go ahead and make a bitcoin.conf file since there's not one here already. I have to install Vim again. apt-get install Vim. Just a quick way to edit files within the terminal. Now I'm going to put vim bitcoin.conf, and in this file I'm going to first press I to represent inserting text, and then I'm going to put in reg test equals 1, and that's all we need for now. So I can go back to the root, go into the proper Bitcoin. So let's go navigate to Bitcoin D here, and now we're all good. The port should be exposed on port 8080. We can even confirm that second part of the port because in the startup message it says bound to 18444, and that's cool. Now we have this step done. Now our Bitcoin D should be accessible from our computer with local IP 127.0.0.1 and the default port for reg test 18443. Now we're going to be calling our node from a Node.js application, which means it's time to program. So let's break out our code editors and flex our hands because, we don't want to get carpal tunnel or anything. All right, hands all stretched. Cool. Next. We'll be programming in JavaScript, so make sure you have Node.js installed if you don't already. And yes, I chose JavaScript voluntarily. And no, I don't hate myself. So let's just move on. Let's start with the installation of dependencies, which we'll need to talk to our RegTest Bitcoin node over RPC. And since it'll be a node package, hopefully it'll be under 1 GB. So this is a short slide, nothing too crazy, which is good because the less packages we have to deal with in the Node.js world, the better. We're only going to need one dependency to complete this task, JSON RPC 2.0. Let's actually make our node project. I'm going to create a folder by clicking on Open Folder, going to my desktop, and typing in Bitcoin D. I'm going to type in hello world Bitcoin D and open. Yes, I trust the authors. And I'm going to open up the terminal here. And within this terminal, I'm going to initialize our project with npm init. Just going to press enter throughout all of this. And the first thing I'm going to install is the only dependency that we need to test things out, which is JSON RPC 2.0. Cool, that's quick. One dependency that is now installed and wasn't 1 GB. So let's thank the heavens. Now let's call get blockchain info using the RPC that we installed to connect to Bitcoin D. The first thing we need to figure out how to do is talk to Bitcoin D using the JSON RPC library. To help bootstrap our application, let's take a look at the docs. Taking a look at the docs is always helpful. So let's type in JSON RPC 2.0 npm. And right in here, we can see the docs. And we want something very simple. We are a client, just a client. And this looks great for our purposes, actually. So let's just copy all this, and we're just going to paste it in to a new file called index.js. I actually want to use common JS syntax, so I will be changing this to, let's try const. And I'm going to make this equal a require statement, JSON RPC 2.0. Perfect, save. Now we need to make some adjustments to this file. Localhost is fine because our Bitcoin D is running locally, but our port is going to be different. And because my port 18443, which is the default port for Bitcoin on RegTest, is taken, I will need to use 8080 because that's what I specified. And all this is part of figuring out which values we need to use. Alternatively, you could have looked at your Bitcoin D Docker container and seen which port we have the RPC running on. If you look up RPC, it should say binding RPC on address 127.0.0.1, which is the IP, same thing as localhost, and port 18443. Okay, so since I bound 18443 to 8080, this should work, right? All this does is initialize the client, but after the client is initialized, we should be able to use the client to make a call. So everything's done asynchronously, so I'm just going to wrap everything in an asynchronous function that I will call main, and I'm going to await a call to the client that is going to be get blockchain info. And let's just call this response. And I'm just going to console.log this response. And then, of course, I need to invoke main at the end. All right. Now that it's time to run the code, we could actually see that nothing happens. And that is another flaw of JavaScript because we are using an asynchronous function, and Node will not wait for our asynchronous function to finish unless we use a top level await, which is available if we were to use a JavaScript module, which I don't want to do because I don't bend to node.js's whims. So instead, I will make a construct that will allow our node.js instance to stay alive while we wait for the asynchronous results. How do I do that? Just watch and learn. What I'm going to do is I am going to add a promise resolved variable up here, and this will be resolved once I get to the last line of this function. But to make sure that this will always give me some resolution, I'm gonna wrap this in a try. And then I am going to add a catch because I want it to show me the error, something happens. And then I'll add a finally, which is going to happen unconditionally. And here I'm going to set promise resolved equal to true. Now down here, I'm going to make a function. I'm going to delete this invocation of main, and I'm going to create a regular function that just says wait for promise. And this is going to check whether the promise is resolved and return if it is. Otherwise, we are going to call set timeout. And the set timeout is essentially going to call itself. So here we're going to call wait for promise again, and we'll set the timeout for 1 second. So when we enter this function, it's going to check the promise is resolved. If it is, it'll return. If not, it'll go and invoke itself again after 1 second. So now let's type in wait for promise. And if I run node index.js again, it's actually waiting for the promise. But there's another error because I forgot to invoke main. Okay, so let me invoke main right here. And let's run it. Okay, cool. So we got fetch failed. Why did it fail? Don't panic because I think I know what happened. Okay, just to reiterate, this is how our file looks like, where we call Bitcoin D for get blockchain info. All right, and if you remember, this is where we are in our Bitcoin container. And I added this line so that we could copy our bitcoin.conf file in this local directory right into the home directory of the container. Now I am going to start Bitcoin D, and we're facing a problem where we would get it to hang. So the first question would be, why is it hanging? And I have some answers to our connectivity issues that we're seeing here. So we do have some missing settings, and the two missing settings are RPC bind and RPC allow IP, both set to all zeros for the IP address. Let's take a look at what these settings mean in the one file that tries to explain it within the Bitcoin Core repository. Within the Bitcoin Core repo, which I have here, if you go to doc and JSON RPC interface, you can see that they do mention RPC allow IP and RPC bind. So I'm just going to read this relevant section. So we can have the context in which RPC allow IP and RPC bind are brought up. And it says securing remote network access. You may optionally allow other computers to remotely control Bitcoin Core by setting the RPC allow IP and RPC bind configuration parameters. These settings are only meant for enabling connections over secure private networks or connections that have been otherwise secured, e.g. using a VPN or port forwarding with SSH or S-tunnel. Do not enable RPC connections over the public internet. Although Bitcoin Core's RPC interface does not use encryption. So your login credentials are sent as clear text that can be read by anyone on your network path. Additionally, the RPC interface has not been hardened to withstand arbitrary internet traffic. So changing the above settings to expose it to the internet, even using something like a Tor onion service, could expose you to unconsidered vulnerabilities. See bitcoind-help for more information about these settings and other settings described in this document. And here we go, related. If you use Bitcoin Core inside a Docker container, you may need to expose the RPC port to the host system. The default way to do this in Docker also exposes the port to the public internet. Instead, expose it only on the host system's local host, for example, -p 127.0.0.1, 832.832. So I don't have any money stored on my Bitcoin node, and ISPs typically have firewalls set up so that you don't get random inbound connections for open ports. But in general, this is a very good recommendation to bind your local host's port to the port within the Docker container to make sure that there are no hiccups with security. I'm not sure if this is a sufficient explanation for someone who doesn't know anything about Bitcoin Core or running it in an application context. So I have my own definitions for RPC allow IP and RPC bind that we'll take a look at right now. RPC bind. Most network programming uses a construct called a socket, which is a programming abstraction that can be used to attach a local process to a network. You can think of a socket as a data structure that contains information about a connection. RPC bind is a way to specify an address in your network interface that you want to listen to connections on. Whenever a packet comes through with the destination address targeting the RPC bind you specified, it'll get picked up by bitcoind. When we set RPC bind to 0000, it's a special IP address that says to listen on all addresses and direct traffic targeting the specified RPC port to bitcoind. Now, RPC allow IP is a setting where we specify which source IP addresses are allowed to talk to our bitcoind process. And I kind of liked this Stack Overflow answer that I found regarding the RPC bind and RPC allow IP settings, which says you could be running Bitcoin Core on your desktop and issuing RPC commands from your laptop. In this example, you might want to put RPC bind 0000 and RPC allow IP 192.168.110 or your laptop's LAN IP. RPC bind binds to a socket. This happens in the networking layer. Without it, packets won't even reach Bitcoin Core. RPC allow IP is used for authorization, which happens in the application layer. And this is the coded line that I thought was very helpful towards understanding what the setting is. It says packets need to be able to reach Bitcoin Core before the command can be authorized. So in a sense, RPC allow IP needs to be a subnet of RPC bind. So what does that mean for running our application? That means now when we run bitcoind, we actually have to put in these settings. RPC bind equals 0000 and RPC allow IP needs to be 0000/0 because we're using CIDR, which stands for Classless Interdomain Routing Protocol. Just a brief detail, but you do need this /0, which is a common source of confusion. So now let's run our application again and see if it still hangs. Ooh, we got something new. Now it is saying unauthorized. Now the question becomes, why are we getting unauthorized? Authenticating against bitcoind. All calls to bitcoind must be authenticated. To authenticate with bitcoind, we need to present credentials in the header of our JSON RPC request that correspond with values within our configuration file, bitcoin.conf. To configure credentials that can be used with the bitcoind node, we actually need to use a script that exists within the Bitcoin source code called rpcauth.py. So let's copy over the file and run it. So this is the Bitcoin Core repository, and I'm going to type in rpcauth.py. We can also go to the repository and type in rpcauth.py. And this is rpcauth.py. If we take a look at this file, we can see a main function, and there's a description, create login credentials for a JSON RPC user. And we have an argument username and an argument password. It says leave empty to generate a random password, which we will because we don't want to specify a password. And ultimately, we will enter one of these conditions. And since we're not going to specify JSON as an argument, we're going to hit this, and it'll tell us what we need to put in our bitcoin.conf file. to help us authenticate, and it'll give us an auto-generated password. It also creates a salt here. What's really going on is in any authentication scenario, just think of web application development, an auth server contains the user's username or email and a hash of their password. Databases should never contain plain text passwords. It should always be hashed with a secure hash function, preferably made for passwords, and include a salt. Now, Bitcoin D kind of takes a similar approach in that it auto-generates a password for you and creates something called an HMAC. And this HMAC also contains a salt. Now, the string that this program outputs that says you should put in bitcoin.conf contains your username and the hash of your password along with the salt. So anyway, let me copy this file over. I will include it within the GitHub repository along with the other files. But in Hello World Bitcoin D, I'm going to paste this file in and save it as rpc auth.py, the same file name that we saw in the Bitcoin repository. So let's see this file in action. Let's type in Python 3 rpc auth, and let's see if we could just get the help information. So here we go. There's positional arguments, which means they should come in order. But we're going to leave the password empty because we want to auto-generate that. So let's type in Python 3 rpc auth.py and just put the first positional argument and call it user, since we'll make that our username. And there we go. It gives us our password and it gives us the line that we need to add to bitcoin.conf. So why don't we copy that over to where we have our Bitcoin Docker file configuration along with our bitcoin.conf that right now is bound to a folder within our Docker container, and place this in and save. Now the question is, what do we do with this password? Bitcoin donation tracker. This next project is the Bitcoin donation tracker. So let me set the scene. You're a hardworking individual named Prem who would like to start an educational initiative to teach financial literacy to those in underprivileged communities worldwide, but are lacking the funds. Whenever a philanthropic venture needs some money, fundraising is always a good start. The Bitcoin donation tracker is a screen that someone who's running a fundraiser, like our hypothetical Prem, can put up and use to watch live donations, potentially up during a live stream previewing the proposed curriculum maybe. I have some code for this project that is hosted on GitHub, and I will be going through every line to help you understand what's going on under the hood. But where do we start? First, we're going to generate an address from a Bitcoin Core wallet. Then we're going to connect to Bitcoin D in our program using 0MQ and listen for transactions and blocks. Then we're going to look for both unconfirmed transactions and confirmed transactions that pay to our address. Finally, we're going to call Bitcoin D using JSON RPC to get our unconfirmed and confirmed balances whenever we detect a transaction that's relevant to us, and send that balance to our front end using something called WebSockets. Overview of 0MQ. 0MQ is a messaging library for servers and clients that implicitly defines its own protocol semantics. 0MQ is used within Bitcoin Core to broadcast live information about the transactions it received in its mempool and the blocks that have been recently confirmed. We will be making a full stack web application with node.js that tunes in to the 0MQ stream from our Bitcoin node and updates a web page if transactions that meet a certain criteria are detected. So this goes back to our step 2 of connecting to Bitcoin D using 0MQ and listening for transactions and blocks. And I guess that third one too, where we look for both types of transactions to see if they pay the address that we have listed for our fundraiser. Let's go over the second concept now. Overview of WebSockets. WebSockets. Earlier, I briefly mentioned sockets as data structures that contain information about a connection. WebSockets are also data structures that contain information about a connection, and are bundled as a class with methods that allow us to establish connections, receive information over those connections, and send information over those connections, accomplishing bi-directional communication. We'll be using WebSockets to keep a stream of information open between the browser and the server. Before WebSockets, browsers adhered to the request response paradigm and didn't have a concept of reusable connections for streaming information over time. So without WebSockets, it would be a lot harder to do what we're gonna do right now. Now let's look at some code. I'm going to be going through this file step by step, line by line, to explain what I'm doing here so none of you get lost. But before that, I'm going to cover some of the changes that I've made to the Bitcoin Docker file. So in this Docker file, this last line changed because I was a little bit tired of directing to Bitcoin 27.1 bin Bitcoin D in the shell. Because before this just opened up the terminal with bash, and I just changed it to automatically run Bitcoin D with the arguments that I've mentioned. So RPC allow IP, RPC bind, and RPC port, which is going to be 8080 since that's what I've been using. Another big change that I've made is in the bitcoin.conf file, I set a new section for our reg test network that specifies the RPC port and a fallback fee. But now that we have all of these options, we're golden, ready to start. So if you haven't, let's run up our Docker file again. And we can do that with this command. And I'll probably copy this and put it in the instructions here. Just call it run. This repo is lacking a README, so let me go and add that. And I'll just put this here as a placeholder. Maybe I'll fill in this README before I actually upload the entire project to GitHub, but I think this is a fitting place for now. So I'm gonna take this command, it interactive -v to bind this local bitcoin.conf file to the directory in my Docker container, -p to bind 8080 on my host to the container, and Bitcoin dev is the name of my Docker container. But I almost forgot, I should probably build just in case I have made changes that I forgot to update my Docker image with. And for some reason, this part always takes forever. That download took a while, but now we're good to go. So I'm going to copy this run instruction from the README and run it right down here. Now I need to verify that it is reg test, and it looks like that because it's mentioning dummy seeds. And it should be on reg test, yep, because we have our bitcoin.conf on reg test. Okay, so now everything is here. Let's move on to the next step of going through our project file. So this is index.js. In this beginning part here, all I'm doing is requiring 0MQ, which is the library that we're going to use to abstract a TCP connection to Bitcoin Core. And then we are going to require this WebSocket. From the WebSocket server, we're going to use this library called Express for node.js to spin up an HTTP server that has really convenient methods for configuring our endpoints. We instantiate an app using this Express library. We require the HTTP module, and that will help us abstract the Express server so that the WebSocket server knows what to do with it. We'll require Bitcoin.js, and we're going to require an RPC client that we have defined within this project. So let's go into RPC client. In the RPC client, we require JSON RPC 2.0, just like we did in the last project. We use node fetch, and we pull some values from the environment variable, Bitcoin D port and RPC creds, process.env. The rest of this is really a twist on what we've been doing. I made this a template string and put Bitcoin D port here. And the RPC creds I used for the authorization header that we need to talk to Bitcoin D using the RPC client. And everything else here is just a slight modification of the reference code that we pulled from NPM in the last project. So now going back to index.js, I pull some environment variables that need to get set here. And by the way, all the environment variables needed for this project are in .env.sample, where I have some sample values here that we can change, or will probably change, at least for donation address. Moving on, we have app.get, which is configuring the get endpoint on our Express server for this root path. This is the callback that handles the HTTP request. It is a Lambda that just takes in requests and response, and we call send file on this response with dir name, which is a node defined value that will get our current directory, and we're just going to serve index.html from it. And this next one is very similar. We're just going to be serving styles.css for that index.html page. And just to take a quick look at that index.html page, this is what it looks like. We have some address here. We have a placeholder for a value and another placeholder for a value. This is going to represent our confirmed funds, and this is going to represent our unconfirmed funds. This is the donation address that we're going to use. Okay, then we wrap our Express app in an HTTP server, again for the WebSocket server. Now we have this run function. I'm not going to invoke it yet. We have a refresh balance function, and we have our WebSocket server defined here that takes in that HTTP server. Then we configure our WebSocket server for connections, and then we are going to listen on our Express server wrapped in this HTTP server on port 9123, which is a port that I don't think is going to be used on many people's computer, but if you want to change it, you are welcome to. So I'll start from the bottom up when explaining these functions. First thing we do is, we listen with our server on this port, but we've also configured our WebSocket server to start listening for connections and responding in kind according to this callback function. This callback function we just called connection takes in a WebSocket, which kind of represents the connection to whoever connected to our WebSocket server, and we can set handlers for events that we get on this WebSocket connection. So on error, we pipe it to console.error. On a message, we use this function called message to handle the data, which is just going to console.log wherever the message is. Finally, on every connection, we call refresh balance on this connection. So if once you connect, we refresh our balance, and I'll tell you what that does in a second. And the other thing that we do is we call run, which is going to continuously refresh our balance, which again, you'll see soon. And both of these take in our WebSocket connection to the browser, because both of these will be sending information to our browser. Well, this one, just this one invocation, but run is a long-lived function and actually ends up calling refresh balance multiple times. So let's go into run, and then we'll go into refresh balance. Actually, let's go into refresh balance, and then we'll go into run. What refresh balance does is it takes our WebSocket connection and it first just tries to make a request to our Bitcoin core node using the RPC client. It asks to load a wallet of whatever wallet name we have defined in our environment variable, and we give an error if it's already loaded. Then we are going to make a request with our JSON RPC client to get the balance and to get the unconfirmed balance of this wallet. And this wallet is going to be assumed to be the only wallet we have loaded on the Bitcoin core node we're using for this application. And once we have our confirmed and unconfirmed, we send a JSON object to our WebSocket connection so that it can get hit by the browser. So we're sending information about our balance to the browser using the WebSocket. So this is a one-time thing. You hit refresh balance and it sends the balance to the web browser. So what does run do? If this gets fired on connection and finishes, what does run, the long running function, do? So run also takes the WebSocket connection. We create a 0MQ subscriber, which is closer to this idea of a TCP socket. And we connect using TCP to our localhost IP and the port that we set Bitcoin to be on, which I've been setting to 8080. Now our 0MQ client is going to subscribe to this topic, which is considered a message prefix in 0MQ, I believe. And this message is classified under raw transaction will just contain raw transaction bytes. And once we're subscribed, I just want to log that we are subscribed and connected to the port that we have set. Now we do this for await, and we're awaiting messages from this socket along with this topic. And we do a console.log whenever we receive a message from this 0MQ connection. We say we received a message related to in the topic, and then we also show the message that I stringify into hex because we receive it as bytes. Then I'm going to use bitcoin.js.transaction.fromHex to parse our hex string that I make from the bytes to get a transaction object that's easily parsable and that I can use to look through the various details of a transaction in a structured way. So after I have the parse transaction, I'm going to make this for loop go through all the outputs of my transaction. And I extract the address from the transaction. And if the address is equal to my set donation address, then I am going to refresh my balance, which means whenever I receive a transaction from Bitcoin Core through this 0MQ stream, I am going to just refresh my balance because I know that a transaction came that altered my balance. And refresh balance just sends the new balance to the browser, both unconfirmed and confirmed. And then if there's any errors, I just catch it since this thing is wrapped in a try. And that's pretty much all it does. And again, this will keep running because it will keep pulling messages from the socket. And whenever we receive a new one, it'll go and refresh the balance if a transaction that was relevant to us came in. This is all we have to our application. It's pretty simple. Let's take a look at the client side. I was going to actually just go over this front end file, but I made a couple changes in between the last video clips and the current one, and I'll probably try and explain those, or I will try to explain those, but I'll do that right after I go over this file. Okay, so this file consists of very standard things. The whole document is wrapped in HTML tags. We have head tags for this portion. We include a style sheet styles.css. We have a body that includes the BTC you saw previously, along with the dash as a placeholder, because this should contain a balance. And if you look here, the ID of the span is confirmed. So this should be the confirmed balance. We have an info container, which contains an address. We also have a QR code, which I added to be generated. And this QR code uses this QR code.min.js library. We have a section for unconfirmed funds, BTC, dash, again, an ID. So it's unconfirmed and a label. And here we have the script, which is maybe the more interesting part. We have connect, which uses show message, which is just equal to console.log, so it doesn't really help with much. We have our WebSocket connection. It connects to location.host, so whatever server that this HTML file is being served from. When our WebSocket is on error, then we will show a message that says WebSocket error. On open, we show a message that says the connection was established. And then on close here, we delete the WebSocket and we set a timeout to reconnect after 1 second. This is just a save on memory. We delete the WebSocket on close. This is usually because we've, closed the lid of our laptop or did something else that caused the connection to be closed. So when we navigate back to the browser tab, we would want the connection to be reestablished. So this is reestablishment logic. It's pretty simple. Here's WebSocket.onMessage. This is what happens when we get a message. We will console.log the event so we can see it in the console in the browser. And then we parse the event's data into a balance object. We will then get the confirmed balance from the HTML and make it equal to balance.confirmed. We'll get the unconfirmed HTML element and we'll set it to balance.unconfirmed. Pretty straightforward. We actually invoke connect. And then this part, set address, we also invoke this immediately after definition because this will go and fetch the address that we need to display from our host or our server that's hosting this index.html file. And then we get the address response as text and we set the address HTML element to the address that we have fetched from our server. This is so we don't have to hard code any addresses. And then finally, we make a QR code using that library I showed above with width 150 pixels, height 150 pixels, and the information it contains is what's defined in the BIP for Bitcoin Your Eyes. I also kind of wanted to go into a side note about that QR code library. It's probably one of the most popular, if not the most popular QR code library for JavaScript, because when I look up QR code JS in Google, it is the first result. And here we could actually download it using zip. You've already downloaded it. And once you download it, you get all these files. And I just took this one. So hopefully that dispelled any magic you thought that was happening in the project. And I just wanted to clear that up before we move forward. So let's go back to what we were doing. Okay, now let's look at the changes that we made in our index.js file. Here we defined new environment variables. If you look down here, 0MQ port, wallet name, port network. We didn't have all of these before. I also added something called Winston, which is a way to establish a logger with different levels of logging. I made a create RPC client that actually makes our RPC client for us. I made a UI directory, which we serve all of our files from, index.html, styles.css, QR code.min.js. And here is the address endpoint that we call from our front end because we don't have static addresses on our front end HTML file. This donation address starts off undefined but gets defined later on. A lot of this should look very familiar. Server Now we're still establishing that. We have a run that will take in WebSockets and call refresh balance on our list of WebSockets down there on line 71. One of the important things here was to decouple this run function, our server-side WebSocket connection logic, because every single time a connection was being established from the front end to our back end, we were invoking this run function, which connects to Bitcoin. So we were making a whole bunch of connections to Bitcoin D to equal all of our client connections, which is kind of a bad thing to do. So I changed that up. It was in memory intensive. You don't need to make all those connections, especially because the connection to Bitcoin D that we're making is always going to give us the same information. So if we open 10 of them, we're not getting any new information or fragmented information from each of those 10 connections. We're getting the same information just multiplied 10 times for each of the 10 clients we have, which is not a very smart way to do things. Besides that, I don't know if there's that much more to show here that you don't already know. Again, client is the RPC client here. You make requests to load the wallet. The wallet should be defined in wallet name. Oh yeah, and this refresh balance that's called from run takes in WebSockets as an argument, which is a list of WebSockets, and then iterates to the WebSockets and sends them each the confirmed and unconfirmed balance for the wallet that is associated with this server. So each of our clients are always going to get the information for our donation address wallet specifically, because they're all trying to monitor the person's wallet who's hosting this donation address. Create wallet if not exists is also new. I try and create a wallet and I throw the exception if the error isn't something I recognize, and the only thing I'm recognizing here is database already exists, and I just log, if it is database already exists, and I set new wallet equal to false. Then I try to load the wallet. And again, if the wallet's already loaded, then I already know what message to put here. And then here I have initialize wallet, which has this thing called initialize, called initialization finished. I default it to false. And in this initialize wallet, we create our RPC client, we create our wallet if it doesn't exist, which is the function we just went over. We create an RPC client, or a default wallet client, and if the network is rag test, then we actually first generate some blocks to fund our wallet with. We get the new address, we generate some Bitcoin to that address. So we start off with a balance, and then we create the wallet of wallet name if it doesn't exist. We create our RPC client that is scoped to that wallet using wallet name. We get the donation address. We log the donation address. And again, all these are Bitcoin CLI commands that you could send to Bitcoin D. If our network is reg test, then we will go and put a log statement, debug log saying scheduling test payment, and we will actually send a payment to ourselves after 15 seconds. So we can just wait, and if we wait 15 seconds after starting the server and opening the page, we should see a live payment come in. And we finish off saying initialization finished equals true. Now, what is this used for? It's used to start server. So we made a function called start server that essentially doesn't start the server until the initialization is finished. And then if it isn't finished, we log that the initialization is incomplete, and that will wait another second, and we set a timeout for 1 second to go and start the server again to see if initialization is finished by then. Then we will call run with the WebSocket connections that we have been establishing. Again, this will establish the connection to Bitcoin D once and just take in this WebSocket connections variable as an argument. Then we'll call initialize wallet, which will create our default wallet and our donation address wallet. And then we'll start the server, which basically waits until our wallet is initialized before starting. Now, WebSocket connections. Maybe you're curious about this. This is an object, a list, and every single time that we establish a connection from our WebSocket server, we will go and push that connection to WebSocket connections. And we'll call refresh balance on this WebSocket as soon as it's connected, just so we can initialize the client with the correct information as soon as possible instead of waiting for updates to be streamed to it. Okay, now I think that's about it. Okay, just like the last project where we had a Bitcoin node running and a separate application that was our node application, we also have a Docker file here. And I actually decided to have the Bitcoin Docker folder inside of this overall project for Bitcoin donation tracker. I just thought it would make it easier if it was accessible here. And I wanted to show that most of the stuff in this file is the same from the last file. We have this from statement that takes from Ubuntu. We have our work directory as app. We copy over the bitcoin.conf to our roots.bitcoin, bitcoin.conf folder. We update by apt-get. We install curl. We go and grab the archive and the SHA-256 sums for verification. We do the verification. We untar this. And here I have something new. It's scripts. There's a whole bunch of helper scripts for me. And I can go more into that as we start our Docker file. I, of course, make this runnable, chmod plus x, configure some aliases, and then I just want to drop us in our bash shell. So I don't want to start Bitcoin directly. I want to be able to close Bitcoin and maybe reopen it. So that's why I didn't make it the main process here. Let's look at the README. For this README, we build. Oh, what is this? So in this README, we build the Docker container. So let's build it because I want to build it just as it is now. And I should probably put more information in here. Docker's not running. Okay, Docker should be running now. Let's try it. Okay, it's already built because I built it in the past. But now that it's built, let's actually run this image using docker run -it-v because I'm binding this volume. So I didn't really explain this, I don't think. The -v is binding this current directory's bitcoin.conf to this directory in our container /root/.bitcoin/bitcoin.conf. I also bind the scripts directory to /root/scripts. -p is just exposing them ports, and I just start Bitcoin dev. Cool, it started. Now I do have my scripts, so why don't we go and configure our aliases? Oh, it's actually in scripts in the root directory. Scripts, configure aliases. Permission denied. Okay. Well, I thought we changed the permission in our Docker file, but there's probably something wrong. All right, but we were able to run it. So now we should have Bitcoin D available to us, Bitcoin CLI. Now, here's a run command that I made for myself just to test various things out. And we could go and run Bitcoin D. How about we just start with that? So /Bitcoin D. Oh, wait, why am I doing /? My mistake. I didn't need /. Bitcoin D. Maybe this alias didn't take. Okay, that's usually the best way to go about things. And again, because we have our bitcoin.conf set to reg test, this is not going to get actual blocks from the Bitcoin mainnet. This should also be familiar. These are credentials I need to authenticate with my Bitcoin node. This is my password, for which this corresponds to a hash with salt4, and RPC allow IP 0000/0, allowing all IP addresses. It's the easiest thing to put. RPC bind 0000 as well. And you probably all know this. This is important. ZMQ pub raw transaction. So you do need to have this set to some value. I put 8089 for my port, but you do need to make this accessible. So this is necessary for the application to run. Okay, well, now that that's working, why don't we try and run our node application, the Bitcoin donation tracker, the meat of the project. Okay, our Bitcoin D is running. Don't panic. I just opened up a new shell here. Let's run our Bitcoin donation tracker. So let's start off by typing npm install to install any and all dependencies that we might need. Cool. And then after we do the npm install, we're going to run a script that we can find within our package.json here. And it's npm run start. And it just runs nodemon index.js. And what this does is it just kind of monitors our index.js file so that if we make a change to it, it will actually rerun it, which is very handy. So let's do npm run start. Okay, and this is fair because I don't think I sourced our environment. So let me go and source that. I have this .env.sample that I would like to source. Source.env.sample. Now let's try this again. Okay, great. I'm getting information, messages, a lot of opportunities. Scheduling test payment starting server. Oof, I might have missed the test payment. Let's open it up. Okay, so here is my page and I have 0 BTC. Okay, I'm a pleb, so not much here. Also, I want to remind all of you out there that all these values are test values. Don't send any Bitcoin to these addresses, even if the address is a mainnet address. I may host the site permanently, and you'll see that in the next section. I'll show you how, but I probably won't keep it up long term. Anyway, the test payment came through here in the unconfirmed funds. So that's kind of cool. Very nice. In fact, let's cancel this npm server and let's start it again. And it should be, well, it has to reconnect and schedule the test payment. But one thing that I wanted you to note is that the unconfirmed funds moved into the confirmed funds. And this is because I'm actually generating blocks and getting those funds confirmed. Also note the unconfirmed funds did come in and that I didn't need to refresh this page or do anything to it. It just naturally reconnected because of that piece of code that I showed you before, where the WebSocket will keep trying to reconnect to the server if it loses a connection. And this is pretty much all there is to this application. I think it is a pretty cool application. It is designed by yours truly. I'm not, a full-time designer, but I think it looks pretty good and it can be useful for some. So now you can go and run your own. I'll try and fill in that README with more information. And again, all the resources that I have, the links for the GitHub will be in the description of the video. But just in general, I want to give you a pat on the back for sticking through this section. I know it's pretty long and it had a lot of information. So good job for watching until the end. Stay tuned for the next section. Hello, and welcome to the fourth and last module, Bitcoin application deployment. I've taught you a little bit about Bitcoin, a little bit about wallets, and I programmed and struggled in front of you so that we could have this application ready to deploy to the world for everyone to see. Deploying Bitcoin Core. Now that we have a working application that integrates with Bitcoin Core, Let's deploy the site to a publicly accessible web server because I did not do all that work for no one to see. For this, we'll use a platform many of you might be familiar with called Amazon Web Services. At the end of our deployment, we should be able to access a site that looks just like our locally hosted donations webpage over the publicly accessible web. No battle was won according to plan, but there also wasn't a battle that was won without one. I'm paraphrasing, but that's a quote from Dwight D. Eisenhower. Point of me saying that is to transition to the next section where we will be planning. It's always good to have a plan. The plan is to 1. Create an EC2 instance on Amazon. 2. Download Bitcoin Core onto the instance. 3. Clone our donation repository into instance. 4. Copy Bitcoin data dir from prune node into instance. 5. Run Bitcoin Core. 6. Run donation repository. 7. Expose ports within security group. Kind of simple, right? Maybe. Amazon Elastic Compute Cloud. An Amazon EC2 instance is a virtual machine hosted by Amazon within their data centers. You might have heard of these before. There's a lot of different cloud platforms like AWS, for example, Google Cloud Platform, GCP, or Microsoft's solution Azure. I just decided to use Amazon Web Services because I've used it a lot for my own personal projects. But EC2, or this idea of VMs that can scale and compute, is something common across all of these cloud platforms. The configuration of these machines are specified on startup and allow a choice selection of system architecture, operating system, compute, and memory. EC2 instances can be accessed via SSH and used just like you would any other remote machine. We will be using an EC2 instance to locally host our Bitcoin D application and publicly host our donation tracker application. Prune nodes. Prune nodes are nodes that delete blockchain data that has already been verified and is no longer needed. Prune nodes are useful in certain types of production deployments where the functionality of the application doesn't depend on blockchain data from before the application was deployed. A prune node will lower the memory requirements of our EC2 instance and allow us to quickly sync the data we need, aka the utxos set. We will be using descriptors to create a watch-only wallet so our production deployment doesn't have access to our private keys. So this is more of the stretch goal. I think it would be cool if I demonstrated how to create maybe a wallet with a hardware wallet. I have a couple Jades laying around. So it would be cool if I made the wallet on the Jade and imported the descriptor on to Bitcoin Core to try and bring all of this together. Node security settings. An important thing to notice about our deployment is that everything we need is on a single EC2 instance. The JSON RPC connection we've been establishing to Bitcoin Core is not encrypted. Not is in bold because it is very important that you see this is not encrypted communication, and you should not be talking to an insecure Bitcoin Core instance over the network, especially if the Bitcoin Core instance has keys, private keys, that have access to funds. And if we place Bitcoin Core on a different public instance and had our application talk to it over the internet, all traffic could be eavesdropped upon. This is why you should only deploy Bitcoin Core for use with an application in a virtual private cloud, VPC, or virtual private network, VPN, where said application can internally communicate with it. So you want to segment Bitcoin Core somewhere such that it cannot be accessed to the internet, but can be accessed to your application. And you'd usually do this by having them share some kind of private network. The RPC port will not be exposed to the public since we can configure rules in something called the security group that only allow explicit ports to be exposed. Our RPC allow IP, along with RPC bind, also don't need to be fully exposed, so we can now limit those values to be our localhost. Although I put this on the slide, I probably won't, and I'll just leave them as they are. If I was trying to be very secure and I knew I was going to leave this application up, then maybe I'd try and configure these values, but I probably won't have it up for long, at least not this deployment that I've done on camera. Creating an EC2 instance. So this step is going to entail me creating an EC2 instance on Amazon Web Services, the AWS platform, and it's pretty simple, so let's follow along. Entering the EC2 instance's shell. So we know what a shell is, we know what bash is, we're very comfortable with terminals around here. I really hope that you're comfortable with terminals because I've been using it a lot in the course. But now we're gonna enter our EC2 terminal. And it kind of feels really cool being able to have access to a VM that's hosted on a big company server like Amazon's. I don't know, I felt like it was really cool the first time I entered this remote machine. We'll be using it over SSH, and Amazon does give us credentials, which we'll see in the following video. So let's get into it. Okay, so here we are on the AWS homepage. We're going to click on EC2, and we are going to launch an instance. So the first thing we have to do is name our instance BTC donation tracker. Bam. We're going to pick Ubuntu because that's the most common Linux distro, and it is what I'm comfortable with using. We have T2 micro that's automatically selected for the free tier. We're going to have to change that later to small. We're going to make a key pair. This is what we're going to use to log in to our EC2 instance using SSH. Let's do a quick check of our network settings. We're going to allow SSH traffic so we can log into our machine. We're also going to allow HTTPS traffic from the internet. And everything else looks good. I actually bumped the storage up a little bit, but that is still not enough for our purposes. So I will make that bigger a little bit later. And we launch our instance. Everything is completed. Okay, from the success screen, we go and click on our instance. Cool, we have our BTC donation tracker instance. Looks like everything's running and working well. We can look at our IP address, our public IPv4's DNS that AWS gives us. And here we're gonna try and log into that instance using SSH. The first part of that process is defining some environment variables that I will use in our SSH command. The first being the PEM file path, which is that PEM file that was downloaded during the creation of our EC2 instance with the key pair creation. The next, I'm going to define a user domain, which is copy and pasted from that screen where it said IPv4 DNS. And then I am going to call SSH-I. I'm going to include the PEM file path, and I'm going to include the user domain, and I'm going to say yes. Also note that the user domain starts with Ubuntu at the IPv4 DNS, so there is a user associated with this session. The default user is Ubuntu. And actually, I just realized that it says permission denied, and that is because I used the wrong PEM file. I used the one that I had for testing. So the one that I actually need to use is btc donation tracker.pem, not donation tracker.pem. So I will go and correct that. And now, wait, we have some permission issue, but we can resolve this. I guess my btc donation tracker.pem is too open. I don't really know how it got like this, but again, we can fix it. Since I'm on Mac, I just made a call to chmod. I typed in 400, and I'm going to SSH back into my EC2 instance. The suspense is killing me a bit. We're inside. Success. Now we can move on to the next step. Nice. Downloading Bitcoin. So this part should be somewhat straightforward. I'm going to copy from our Bitcoin Docker project some of the config settings from bitcoin.conf, some of the commands I have in the Docker file, and some of the configuration settings I have in bitcoin.conf. But the copying of bitcoin.conf will come a little bit later. Okay, so this is a quick look at our Docker file from our Bitcoin Docker project. I would just like to copy and paste the apt-get update, but I got permission denied. So what I'm going to do is I'm going to run it with sudo, and everything is working now, which is good, though it makes us wait a little bit. Okay, cool, done. Now, next line. A bit of an arduous process, but I think it's important to follow the steps exactly. Okay, that's done. Now we are going to call curl to get our Bitcoin files. All right, quick and easy. SHA 256 sums was like nothing, so quick. And let's just verify, because that's what we have in our Docker file. And I want to achieve a type of parity here. Okay. Now let's just open our archive file. Nice. So we downloaded Bitcoin D and Bitcoin CLI onto our EC2 instance. All ready to go. Okay, so before I get too far into anything else, I wanted to increase the size of our EC2 volume. So I am making some changes on the screen right now to go into the EC2 instance and look at its volume. That's the old instance, mistaken one that threw me off when I was first using SSH. But this one is BTC donation tracker. You need to go into storage. We'll click volume. Just select it again, actions, and modify volume. And I'm just going to make this a lot bigger. 40 gigabytes should be fine. And we can read this, but I'm sure I would like to modify this. But since I'm here, I might as well read it. So if you're increasing the size of the volume, you must extend the file system to the new size of the volume. You can only do this when the volume enters the optimizing state. For more information, see extend file system after resizing an EBS volume. And honestly, we don't have to worry about any of that stuff. Everything will just work. Okay, and finally, we can go back to instances since we had to stop it to resize the volume, and we're going to restart this instance. So we select it, go to instance state, and then start instance like I just did. But we can also SSH back into our instance and do some checks there to make sure everything is all good. Looks like we might be facing some technical difficulties. So I just control C and went back to our EC2 instance details to make sure it's running. And it is running, so let's go back. Okay, an important thing to note, I just realized it, but the public IPv4 DNS can change, and it has. So I'm going to copy and paste this user domain because this does not match the one that we are now assigned. So let's just set this. Okay, and we're in. So now let's type this in, lsblk. I just want to make sure that things were resized appropriately, and it does look as if things were resized. So we're good there as well. Pruning our node. So I haven't really went into downloading Bitcoin Qt, which is the GUI or the graphical user interface that most technical people who aren't programmers and don't like the terminal will use. I thought it would be good if I just showed you how to download Bitcoin Qt and how to prune your node. So here goes it. Okay, so this is bitcoincore.org. We're gonna click on download. This is the most official version of the Bitcoin Core website that's actually listed on the Bitcoin Core GitHub. And I'm just finding a place to download this. Desktop is fine. And there it is. Let's unzip. Okay, now let's open it. And it gives us a message. So you actually have to right click it and click open and then open again. Now we get some settings here. Honestly, all this is fine. Blockchain storage to 2 gigabytes at the bottom is just saying that we're going to prune, and we're going to use the default data directory because that's what we're used to. Feel free to read the rest of this. And an error. I have the port in use. Rats. Okay, I think I successfully killed that process that was using that port. So this is kind of cool. It's working. I had the ticker in the bottom right that allows you to click on different subdenominations, and we are at 0.00%. It is calculating the approximate progress per hour and the estimated time left until synced. But to do that, it needs to sync the headers, which is what you saw at the top there. So now we wait for the headers to sync and eventually wait to download the blockchain. All right, so this is the blockchain already downloaded. I'm not going to make you sit and watch as the blockchain is downloaded. And bam, this is what it looks like when you're synced. Copying the data dir to our EC2 instance. So this step is me having my Bitcoin node run locally. It's pruned, it's synced, and I just don't want to do this whole process again over my EC2 instance. I don't want to wait for the entire sync of the blockchain and the entire verification when I know I've done it. So I should be able to pick up my data directory that I use for my own Bitcoin core, which has no wallets loaded on it, and copy that to my remote instance so that it can get bootstrapped with all the blockchain information and information about the utxos set, which is what our application actually cares about. All right, next step, we are going to try and transfer our data directory from our local Bitcoin node, whether spun up through Bitcoin D or Bitcoin QT, into our EC2 instance. We're gonna use something called SCP, which stands for Secure Copy -R, so that we can recursively copy over those files, which basically means copying a folder and all its contents. We're gonna specify interactive and a PEM file path, which I still have loaded up with the directory to our PEM file, and of course our user domain and the location and the user domain. Okay, small hiccup. Okay, I had a small brain fart here. And I actually need to reset our PEM file path and reset the user domain because this is a new terminal window. Now let's try it again. Okay. No such file or directory. Okay, I went to users demo library, application support, where demo is the user I'm using. And this is a little confusing. I feel like I'm getting gaslit by my terminal right now. Everything reminds me of her. Okay, but we'll keep on moving. Let's replace the tilde representing home. And let's just put the whole path in. And there we go. We're off to the races. Actually, a very slow race because these transfer speeds are abysmal. Well, I probably shouldn't make you wait and watch through all of this, so I'm going to skip ahead to the next section. Cloning the donation repository. So I've uploaded the code for Bitcoin donation tracker onto GitHub. I have been developing it along with you guys on camera, but this version is the ultra tweaked version, and I'll get into that a little bit. And then I'll just clone the version that I put on GitHub. Okay, this part is a lot simpler because most developers have cloned a repo. So I just SSH'd into the EC2 instance, and I'm just gonna call git clone on my repo for Bitcoin donation tracker. And bam, it's all cloned. ls, we're gonna go into the folder and npm install everything. But first we have to install npm. Okay, just some setup troubles. 714 megabytes, that's huge. There's a lightweight way to install npm, but I did not do that here. And now more waiting. You know, a lot of this involves waiting, but it's okay because patience is a virtue. And we're finally done. Great. Let's call it npm install again, now that we have npm. And I have almost no dependencies on this, so it goes pretty quickly. There we go, pretty quickly. So now let's move on to the next part. Running Bitcoin D with screen. So when we SSH into our remote EC2 instance, we're in its current shell. And when we run an application from that active shell, there's not really a good way to end our session with our remote machine. I would have to do Control C and exit, or I'd have to wait for some type of timeout, in which case that active shell is going to get destroyed, dropped. So I use a tool called Screen a lot for my personal projects, where I'm able to have background shells that can spin up different processes so that when I leave the terminal, I'm not actually killing my application. So now it's time to run the donation repository code. I'm hoping this process is easy, silky smooth waters. I don't have any more challenges because, you know, I've been through it. And we'll just have to see how it goes. Okay, so we are in our EC2 instance. I'm just going to type ls, list out our directory, and I'm going to run this command I told you about called screen. And from here, all I really want to do is start Bitcoin. And we can do that by just going to Bitcoin 27.1 bin Bitcoin and doing Bitcoin D. And we are now syncing. It should use the data directory that we copied over from our local machine. So this process shouldn't be very long. The bulk of the time should have been spent actually trying to transfer your files from your local directory over to this remote EC2 instance. But from here, it should be smooth sailing. All right, so to exit from screen, you're gonna do Control A followed by Control D, and that'll remove you from the screen. So that's how I detach there. Okay, now let's do the same thing for Bitcoin donation tracker. I already started screen in the background, and we can already see that I got an error here. Now let's look at what the issue is, and it is with our environment file. This network needs to change from reg test to mainnet. The port is good, RPC creds is good, because that is what's set in our data directory. Donation address is fine, I guess. And one more thing I have to do is copy over the settings from bitcoin.conf, because I just remembered my local Bitcoin directory that I copied from is just a regular nodes data directory that hasn't been modified for our Bitcoin donation tracker application. So now everything should be good, or at least on its way to being good. Okay, wanted to check on Bitcoin, make sure it's working okay. It does seem to be working okay. All right, and now when I call this, I get verifying blocks, which is fine. Just means you have to wait a little bit and try again. And bam, a new error. So we have permission denied on port 80. Let's see why that is. So here's our EC2 US console for our EC2 instance, and I am in the security tab, and I just clicked on the security group, and I'm gonna edit the inbound rules. So these are like network rules. I have SSH and I have HTTPS defined, but I don't have HTTP, which I need because I don't have TLS on my application right now. And I'm just gonna set it to the everything address. So listen, on everything. And this should fix it. Checking our deployment. Right, now, if everything went according to plan, and if the powers that be aren't rooting against me today, then we should be able to go to the URL in our EC2 instance pane that our EC2 instance is accessible from. And we should be able to see the Bitcoin donation tracker website on port 80, which is what we're hosting on. We do not have TLS right now, so you can't put HTTPS, so you have to make sure it's just HTTP. When you copy that link, you're gonna have to modify, and it should be good to go. So let's try it out. Okay, so now it's time to check our deployment, and we can do that through looking at the URL attached to our EC2 instance, and unfortunately we get this message: the site can't be reached, and then the site can't provide a secure connection, which we know because we did not enable HTTPS, and I changed it to HTTP, and we see it working. Awesome. Don't send anything to that address, by the way. I discarded that wallet. Success. Thank the heavens that this thing is actually working. I mean, I thought it would work from the beginning, of course, but I'm still surprised that it went smoother than I thought it would. So, let's give a round of applause to ourselves if you've been following along. And unfortunately, this is where I'm going to leave you because this is the end of the course. But before you spend too long crying, I'll put out there that I will be doing more videos for Bitcoin Nation. I also have a YouTube channel called Understanding Bitcoin Source of a previous series that I used to do at the Bitcoin Grove, which is a Bitcoin hackerspace in Miami. And I don't plan to end the Bitcoin education here. Hopefully I can improve every single time that I do something like this, and my videos can be better, so feel free to leave feedback in the comments and let me know what you would want to watch from me next. Thanks for watching.